Testing, testing. YouTube, can you hear me? And this one is okay. And we hit record. Okay, then we can finally start. Hi, I'm Per, and I'm founder of PasswordsCon and a highly informal person. Once upon a time, I was also military police. So that means there's no way you can offend me, more or less. I've heard everything before. Hashtag is PasswordsCon. And in case of an emergency, like a ransomware attack, you're on your own. I don't have any survival kits under your seats. Fire exit out into the street and wait there. Thank you to our sponsors. Detak from Germany. Octav, where are you? Hey, there he is. He will be doing a talk this afternoon. AID, which I'm actually serving on the board for, and also Transcendent Group that has been helping us out with this room and a few other things. And with that, I will start quite a bit delayed, so this is going to be a hard one. What did PasswordsCon ever do for you? The kitten slide, no advanced math in this presentation whatsoever. This is basically sort of a summary of, I'm not going to say the best talks, but at least the talks that I think really do cover the very wide topic of passwords, PIN codes, and all kinds of digital authentication. I started the conference in 2010, but my interest in passwords came about when I was working as a pen testing consultant for PwC. I started there in 1998 in order to set up penetration testing as a service. And somewhere in the world, I was in engagement for a Fortune 500 company, and on day one of the assignment, we set up a null session towards the domain controller. We pulled out a list of tens of thousands of user accounts, and then we set up a very simple script saying, for each account, try to log in using the company name as the password. And if that doesn't work, try the word password. And we started the script. We were 3 guys there, and sometime during the day, the script said bingo, and we had one single user who was using password as his password, because it was a man, I'm going to say, obviously. And that account was a member of the domain administrators group on day one, Fortune 500 company. And when you experience that, and we were 3 guys there just standing up and taking like 3 steps back and like, okay, guys, you know, life choices, this is the moment. Go criminal or stay consultant. And here I am, so obviously, wrong choice. And that was the first starting point with my obsession into passwords, because you would expect a Fortune 500 company to have pretty decent security even back then. But one single person, one account was the reason for why we could take down pretty much everything. So in 2010, I did the very first PasswordsCon here in Bergen at the university and sponsored by Professor Tor Helleseth. We were almost this amount of people physically in there. Howard Smith from Oracle was the first speaker on stage. He was talking about pins, users selection in pins. So for those of you that are working with pin security or looking into pin codes, I'm going to say that's a talk you sort of like, you should watch that one. Yeah, Kirsi, you're here as well. Kirsi Helkala, she was at the very first PasswordsCon. She will also be talking here today. And she talked about password education based on guidelines tailored to different password strategies. Her talk is, and I am also looking forward to your talk today, no pressure, but I think that she brought into the conference an important perspective from the very, very beginning, how to educate people on how to create good passwords that you can also actually remember. Because sometimes people say that, well, a good password is something you can't remember. It shouldn't be like that. James Nobis talked about rainbow tables, so I actually forced him to talk for almost 3 hours because I didn't have that many speakers submitting for the very first conference. Now, rainbow tables didn't really stand the test of time, so today rainbow tables are really not used for much anymore. But more interesting, I also had Dmitry Samin, the president of Russian company Password, that are doing forensic software, talking about cracking full disk encryption in minutes with live memory analysis. And what he showed live on stage was essentially a laptop that was locked, and he plugged in using FireWire. That is a connector that we don't use FireWire anymore. Now it's turned into Thunderbolt and USB-C. But with FireWire back in the days, you had 32-bit memory addressing. So using his own laptop and connecting using FireWire to a Windows laptop that was locked, FireWire gave you direct memory access, bypassing all kinds of operating system security. So what he could do, he could essentially set the password to 0 in memory, running memory of the computer that was locked, and just then, on the lock screen, just press enter, boom, you're in. That was a pretty cool trick to see being done live. And I talked about a little bit about password usability. Even back then, I said use a sentence as your password, because using a sentence is something that at least I consider to be pretty easy. In fact, I do say today I use a positive sentence, something that you want to remember, something from your past that doesn't change in the future. So stay away from your wedding date as an example. Kind of hard. And I talked about that. It was so successful that I did it again in 2011 in June, so only 6 months later. And here we had Simon Josefsson from YubiKey introducing the YubiKey. A long time before FIDO Alliance was started, and a long time before anybody knew about the YubiKey, I purchased a very early, more or less beta version. I plugged it in at home and nothing happened, and I was like, okay, and I'm supposed to do what with this? It has developed over time. I also convinced Professor Frank Stojano from the University of Cambridge to come to Bergen to talk about his paper and project Pico, No More Passwords. Really, really interesting concept where, the basics of it would be to say that, well, we don't have just a password which is yes or no in a world of authentication. We will have different levels. And he said, we will do this in hardware. So you can have earrings, you can have a ring on your finger, you can have several fingers. And the more of these devices that you have that will talk to each other using Bluetooth or some new technology that we haven't invented yet, we have different levels of how certain are we that it's actually you. Pretty cool project, but it did stranded after a few years, but again, really interesting to hear about. I also had Dmitry Sklerov from Elcomsoft. Yes, he's the famous guy who was talking about how to crack Adobe PDF encryption in the US, and suddenly FBI came and arrested him, so he spent quite a few months in prison in the US. He is incredibly good at cryptography, especially at breaking it and doing reverse engineering. I also had Carsten Martmann-Moe from Ernst & Young talking about endpoint security and mobility. The really cool thing, I still have the video, you will get to see the even-made cold boot attack. So a Windows laptop, it's locked. He flips it upside down, remove the panels, use cooling spray to cool down the memory chips for a couple of seconds so they got really cold. And then he flips it around again. He just turns the computer off and boots a very small Linux distribution from a USB key. And since the memory chips in the computer have been cooled down, memory is still preserved. The memory chip still remembers what was in the system when it got turned off. So booting this Linux installation, running a small script, he searches through memory and he finds the key in memory so he can get access to the computer. Pretty cool attack. And then in 2012, Professor Audun Jøsang from University of Oslo assisted me in doing the conference at the university in Oslo. It was in December. We were down to minus 18 Celsius degrees. So that was pretty cold for some friends coming in from Texas, dressed as they were, well, in Texas. We had, I would say, groundbreaking talks there. Jens Stoiber, the author of Hashcat, talked about exploiting a SHA-1 weakness in password cracking. Max, this is still being used for educational purposes. He figured out a weakness in the SHA-1 function. The talk is just, I don't understand anything of it, but it's still really, really amazing. I also had Christophe Rosenberger from France talking about keystroke dynamics, that's biometrics, but looking at how you sort of behave or how you type on a keyboard. And during his talk, he said that, well, what we have done, we have put up a keyboard inside a room, and we can tell people to go in there and just start typing on the keyboard. We don't know your gender, age, we don't know anything about the different people typing on that keyboard. But when you are somewhere in the area of 7 to 8 keystrokes, we have enough information to tell you whether you are male or female. And I was like, wow. Men and women are different, yes. But in that area, I had no idea. And this can, of course, then be used. And there are websites that are using that technology today. When you type in your password, they will also generate a keystroke dynamics profile of you. So that can be used as a flag of whether this is a suspicious login or not. So fraud detection, simple as that. Tor Orderløkken from Norway talked about the password survey that they basically did ahead of the conference. That was, asking about what kind of passwords do you have, how many passwords do you have, how were you given them, how do you create them, and so on. And I will get back a little bit to that survey later in the conference, because one of the things that I've been talking about before as well is I think password surveys are complete utter crap. People who are doing password surveys, in my opinion, they don't know what they are actually asking about. Very simple example, there's a difference between asking how many passwords do you have and how many unique passwords do you have. And even if you ask both questions, you still have to ask how many accounts do you have. And if I ask you how many passwords do you have, most of you will not include the number of PIN codes you have. A PIN code is a shitty password. Sebastian is here as well. He talked about hunting for passwords, so putting an end to the arms race. Sebastian is the one person who pulled out everything that looks like a word from Wikipedia and from other wikis as well, and created a word list. So that word list got very, very famous ahead of the conference. People got crazy because this was an excellent input for cracking passwords. Jeremy Gosney did a lightning talk in the evening where he basically launched his own company building high-performance clustered GPU solutions for cracking passwords. Back then, he had 25 GPUs interconnected between different computers, so he was heating his home using that. Jeremy Spillman talked about data pools and blind hashing security through obesity. Interesting thought. It is just, let's generate so much data that in order to actually steal password hashes from a database or a company, it is not just about pulling out a MD5 or SHA-1 hash, but it will be hidden somewhere in, let's say, 100 terabytes of data. And in there, your hash is stored for your password, but you don't know exactly where. So in order to steal all the password hashes, it's not just a simple Unix password file, it is 10 terabytes, 100 terabytes, 1,000 terabytes of data, which is an interesting concept to discuss. Steve Thomas is just awesome in cryptography of breaking it, hashing algorithms, the good, the bad, and the fail. He talked about that. Interesting talk, and again, MD5, SHA-1, Argon, and bcrypt, and so on, PBKey DF2. And we had Johan Dahmen, the author or inventor of AES, and also Ketchup, which is now SHA-3, talked about that.
Can I just make a comment?
Yeah.
I think Jeremy Gosney, he had an alternative title of his talk, which was Exacerbating Global Warming, which made me very happy to see that the passwords community is aware of the climate challenges.
That's correct. He did that one as well. Yeah. And it was in 2012. Jeremy Gosney is from the US, and he's the guy who told me that, Per, you got to go big, you got to go to the US. And I was like, I'm Norwegian. We never go big on anything. We're just here up in the mountainside and like, hello, Europe, can you see us? But he convinced me to do the conference in Las Vegas as well. So we did that the first time in August 2013. Jeff Goldberg from 1Password was talking about defining password strength. I would say that is still an ongoing topic. Steve Werby talked about crunching the top 10,000 websites' password policies and controls, which is, do you have any idea how much work that would be? Dominic Bongard talked about de-anonymizing users of French political forums. When I got this proposal, I was like, okay, so far we've been talking about passwords and security. Now we actually have a real talk about something that can really affect people in good ways and bad ways. But it was an interesting talk and also a little bit, politically sensitive, so to speak. Jean-Philippe Ormason also talked about and launched the password hashing competition. So motivation, challenges, and organization of that. We again had Jens Stoiber from the author of Hashcat talking about how to use Hashcat properly. There was also Bruce Marshall talking about the review of real-world security questions and answers. Jim Fenton from the US, one of the authors of the NIST SP 863B. Jim, what do we think about security questions? Yeah, very simple. That's the answer. And we also had Rick Redman from CoreLogic. He's the main guy running the Crack Me If You Can competition every year at DEF CON, talking about cracking corporate passwords. Now, to me at least, there's a big difference between corporate passwords and the passwords people are using for Snapchat and Facebook and in general services that you don't care about on the internet. Because on the internet, most services, they are interested in onboarding you as quickly as possible, so make it easy. That means a very relaxed password policy. Companies in general have stricter policies. 2013, back in Norway as well, so I did the conference twice that year. Katja Malvoni from Croatia, if I remember correctly, came here to do her first talk about energy-efficient bcrypt cracking. That is a project for her master thesis that she got from Solar Designer, the author of John the Ripper. And she was using different FPGAs and using assembly language and low-level C to crack bcrypt hashes. And the goal was not to do it as quickly as possible, but to use it as energy efficient as possible. So this is FPGA programming. This is bcrypt hash function or password storage mechanism. And there's programming and everything. And everybody who listened to that talk in Bergen and in Las Vegas next year as well, they were just like, wow. So that talk is really cool. Janice Payne from Cambridge Pico Project is a psychologist. So then we also had this as the sort of first talk about how do people actually use their brain in connection with passwords. A friend of mine, Jan Fredrik, talked about the problem with users, and he launched the password meta policy. He said that every time you are to set a new password, the password meta policy will generate a random password policy for you. And if you fail at that, you get a completely new password policy again. And like a year ago, I think, Troy Hunt launched what he called the password purgatory, yes. People contact Troy Hunt, they want to cooperate and sponsor and blah, 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 and here's a product for you. And he responds really nicely, okay, yeah, that's really interesting. Here's a website for you where you just have to register for an account in order to do business with me. And the password policy, if you type in password, it will say, yeah, but you need a number as well. So you write in password 1, and then it says, yeah, but you have to include the word cat in your password. And it just goes on and on and on and on and on and on. So there's no way you can set up an account in order to do business with Troy Hunt. And of course, he has some counters in there as well. So he's seen people trying like 40, 50, 60 times before they actually give up and understand he doesn't want to do business with me. It's pretty cool. Markus Diermuth from University of Bochum in Germany came here also to talk about wasted computing cycles. But to me, the really interesting part is when he also had some spare time. So he talked a little bit about graphical passwords, specifically Android lock patterns. And he said that a very large amount, 40% or something, when you have the 3x3 pattern lock on Android phones, he said that a vast majority will start in the upper left corner. And, well, I'm left-handed. So I was sort of curious, like, well, what about left-handed people? And Markus said, well, we haven't looked into that. So that turned into a master thesis from a student here in Norway that I was co-supervising, that we'll get back to. Chris Warrington talked about authentication using visual codes. What can possibly go wrong? I will get back to that a little bit later on as well. And Andrei Belenko from Elcomsoft in Russia talked about iCloud keychain and iOS 7 data protection. 2014, Julia Angwin came, a Pulitzer Prize winner. I talked about email security because we do password resets and we send our passwords by email. So to me, passwords in emails are very important to protect. Okay, so I take a genuine interest in email security. I take an interest, again, Jim is one of the people in the world that have done amazing work and are doing amazing work in trying to improve email security. How many remember email? How many actively use email every day? Yeah, okay, so you're not that young, okay. My daughter is 16, she doesn't know what email is, more or less. She never uses email for anything. Rick Redman talked about password topologies. So he looks at patterns. So he said that instead of blocking specific passwords, like password 1, 2, 3, 4, 5, 6, 7, 8, he was looking at patterns like first letter is capitalized, the rest is lowercase, and then you have a number and exclamation mark at the end. That's a pattern. Uppercase, lowercase, one digit, and special character. So he said that using the tool he developed, Pathwell, they could block different types of patterns, the most popular patterns. And I said, if you implement that in any corporation, I'm pretty sure your users are going to hate you. And he said, well, but passwords are going to be really, really good. Carnegie Mellon was there to talk about a little bit about Carnegie Mellon University have been doing in preventing bad passwords. Yannis, he's on Team Hashcat. He is one of those guys that are incredibly good at figuring out patterns in use of passwords and creating Hashcat rules for cracking passwords faster than anyone else. There were talks about password hashing competition candidates. Daniel Reich threw the user ID down the well. He said, we talk about passwords all the friggin' time. We never talk about whether your username should be a secret or not. Twitter, you can log in using your email. You can also log in using your Twitter handle. And if you register a phone number, you can use the phone number to log in as your username. Now, Twitter doesn't allow you to select which one of these to use and which one should not be allowed, because my Twitter handle is easy. That's my last name, Torsen. So it's not a secret. My email address, in most cases, is not a secret. My phone number could potentially be a secret, or at least a little secret, a small secret. So why not allow people to log in using that instead of an email? So just make the username a secret. And Dominic Bongard came with a surprise talk. He talked about offline brute force attack on Wi-Fi protected setup, which is today known as the pixie dust vulnerability. And that made the headlines in international press. Ars Technica and other media were all over this one. So he talked about it first at PasswordsCon and then at Black Hat. And at Black Hat, it was like, whoa! And we're like, it's old news. Pretty cool. 2014, NTNU University in Trondheim. That was the first time we did proceedings. Unfortunately, most of the video recordings have been deleted by the university. I'm sorry about that. Frank Stoiano from Cambridge and 2 students, they talked about password manager friendly PMF, semantic annotations to improve effectiveness of password managers. Basically, put in a little bit of information in your website telling a password manager, these are the composition rules that you have to live by on this site. So this is the minimum, this is the maximum length. We need uppercase, lowercase, or DNA samples, stuff like that in your password. And here we also had Marte Løge. She did her master thesis based on the work from Markus Diemut in Bochum on Android patterns. So this was her first talk about that. We also had Junice Payne again, talking about, from a psychological perspective, what users think, what users know, what users actually do. And we had two amazing talks from Alec Buffett. Back then, he was working for Facebook on the authentication team there. So he talks about how Facebook, in 2014, how passwords were being hashed at Facebook and how they did authentication. And he also talked about the password cracker crack that he developed and launched in 1991. Back in 1991, he was working at Sun Microsystems as an engineer there. And Sun Microsystems, they got hacked by Kevin Mitnick in the US. And if you go online and watch this video, because Alec has a copy of it on his YouTube site, he actually says that when Kevin Mitnick broke in to Sun Microsystems, Alec Buffett was using his own crack program to crack the passwords of Kevin Mitnick. And Kevin Mitnick had shitty passwords. So a little bit of fun there.
Would it help for the previous ones to like crowdsource the videos? I think I might have at least a couple.
I would be more than happy to get them back online, yes, because they were in the video collection of the university. The university were doing all the recordings. But many years later, they said to staff and everything that if you have videos with us, let us know if you still need to keep them. Not being at the university, I totally missed out on that, and suddenly they were gone. So, yeah. 15 again, back to Vegas. Mark Burnett talked about no more graphical passwords. This was a rant talk for Mark. He's pretty cool. Once upon a time, he wrote a book called Perfect Passwords. So that does exist, a book on how to do perfect passwords. And he said he had been looking into different visual authentication schemes, and he had found more than 18,000 patents. And he just basically said, this has to stop. This is complete madness. I had somebody from Google, I can't actually remember his name, but today they have an integrated password manager. Back then, this was a small plugin developed by them that would give you a notification of the password you're now trying to use at a certain website have been compromised, so that's not a good idea. Today, that's a function within Google Chrome and from Google. Cormac Hurley Microsoft Research talked about pushing on string legends in the don't care regions of password strength. Jim Fenton talked about security questions considered harmful, so there you have like the don't do that. Marte Løge talked about tell me who you are and I will tell you your Android lock pattern. That talk she also did at DEF CON. And later on, together with Markus in Bochum and also a professor at NTNU here in Norway, they also published an academic article on that topic. And I talked a little bit about this keystroke dynamics because I was thinking from a privacy perspective, I'm not too happy about people making a biometric profile of me, at least if I do not consent to them doing so. So I was thinking, how can we sort of break this thing? I will get back to that probably this afternoon a little bit. 2015, Frank Stoiano invited me to do the conference at the university in Cambridge, which was really awesome. I do not have even a bachelor's degree from university. I can't do math at all, and I can only do Hello World and Commodore 64 basics. So being invited to the University of Cambridge, to Trinity College, and sponsored by the Center of Excellence in Cybersecurity Research is still a dream to be. And I was pretty cocky with my parents over that. Haha, I'm at the University of Cambridge, and I don't have a university degree, suckers. Not a nice thing to do to your parents. Scott Helm, a friend of mine, he talked about HPKP, HSTS, and CSP for securing your password. That is preventing people from stealing passwords from websites through cute little web tricks. Janice Payne again, debunking graphical password myths. Nasir Menon from New York University talked about verification code forwarding attack. This is essentially SMS, how to trick people into forwarding an SMS code that they receive to somebody else, to the attacker. So in 2015, we talked about SMS spoofing and similar techniques. And even today, companies are still deploying SMS-based authentication. I'm like, don't do that, especially if you have something serious to protect. John Milliken at Facebook talked about Facebook introducing open PGP support. So you can, even today, you can upload your public key to Facebook, and every single email they will ever send to you will be encrypted using PGP. And here's a fun trick. If you upload a PGP key that expires very soon as that key expires, Facebook will never send you an email again. I didn't say that. Angela Sass talked about users hate passwords, so are they on their way out? Angela is really good at the psychology and UX side of things. I've tried arguing with her once. Didn't work out well for me. And Sebastian again talked about word lists, and honestly, and correct me if I'm wrong, but the only thing I remember from your talk is that Han Solo is mentioned in the Bible. And I will leave it to Sebastian to explain, wait, what? So that's your question for Sebastian in the break. Where in the Bible and how did Han Solo from Star Wars end up in the Bible? But he's there. And Alexandra Strigonkova from Moscow in Russia talked about to whom it's not concern, ethical problems of information leaks research. She suggested this to me. She's married to a Russian guy who's really good at cracking passwords. She has a background in psychology. And she said to me that, don't you ever think about what you're actually doing? You download tons of data leaks, usernames, password hashes, plain text passwords and so on, and you're cracking it, you're doing statistics and making fun of people that have shitty passwords. Ethics, morals, legal issues? I'm like, nah, this is too fun. But that was sort of like a really good start on that topic as well, and to me it's still an ongoing discussion, some of the ethics on the things that we actually do. 16, Laurie Craner as a keynote speaker from CMU. Jim Fenton talked about toward better password requirements. This is before the current version of the NIST standard. So Jim has been with us and he's been actively involved with the, I'm going to say very actively involved with PasswordsCon and getting input from people all over. What do you think about we should put into the next version of the NIST standard, which is also something he will be talking about today. Mikael from Czech Republic disclosing password hashing policies. Again, wow, why didn't we think about that before? You have an amazing password, you have many amazing passwords, but you are absolutely clueless on how different services are actually storing your password. What if they are storing it in plain text? Then your password strength doesn't really matter much at all, does it? So he said that you should disclose how do you store your customers, your users' passwords. Now, I'm not going to say that's a failing project, because some actually do, but the very vast majority, they don't. And then it's really up to you to try to guess, how are they actually storing my password? This one, I think, is maybe one of my top 5 talks ever. It's online, Skala Nagao and Florencia Harevega. Passphrases for humans, a cultural approach to passphrase word list generation. This is absolutely awesome. If you know Diceware, a word list of 7,000 something words, and you pick 5 truly random passwords out of that list, and cryptographically, that is a 100% unbreakable password. The problem is, with 7,000 something words and you pick 5 random words, how do you remember them? So they looked into that and they generated a new word list with several criteria. There's a minimum length and a maximum length to the words. The words needs to be known to the average English/American person. Okay, well, that's a certain no offense, Jim, but that does narrow the scope of words a little bit. But not only that, they also said that these words, when translated into other languages, because they created this list in several different languages, the words should not have a double meaning, a double standard. If I say sex, when I pronounce that as sex in Norwegian, it will either be the very interesting number 6, which, ooh, wow, that could be a pin code, that could be part of a password, or just the boring sex stuff. But I mean, it means both things, the same way to pronounce it. So they said, we want words that when you translate them are not profanity and they don't have double meanings. And they also said that it should be easy to pronounce the word in case I have to provide this passphrase to you, Ashley, as an example, over the phone. So if I do, well, anything in Welsh, I don't know Welsh, but if I did anything in Welsh, I just imagine that's going to be hard to listen to on a phone. So they should be easy to pronounce. And last but not least, what they also did in their research work, they were looking into how easy are these words to type on a keyboard. Because some words just force you to look down on your fingers when you do touch typing. And some words are easy to write, others are hard. And that talk is like absolutely amazing. And we also had Arnold Reinhold, which is the guy who invented Diceware, talk about rock salt, which again is back to what Jeremy Spillman did in 2012. We have a gigantic database of random data, and somewhere in there, your password is stored in some sort of hash format. In order to steal it, you have to copy out all the data in order just to recover a single password, like a 100 terabytes of data. We went to Bochum in Germany. Peter Meyer talked about, well, you use computers and iPads, but maybe you have a PlayStation or an Xbox and you want to type in your password using a game controller. So how can we do that a little bit easier, or how can we automate that stuff? I'm an Xbox player at age 51. I'm not ashamed of that. But entering a password on screen using our game controller is, especially when you use like 30 plus random passwords from your password manager. That takes some time before you can actually start playing. Oleg Afonin from Elcomsoft talked about two-factor authentication in major mobile platforms, where we talk about both two-step verification and two-factor authentication, which is a difference. David Jäger from HPI in Germany talked about public leak credentials and a long story of password reuse. Oh, I'm supposed to stop? Well, I don't care. And Khalid talked about adopted keystroke rhythm for password hardening. So here we are back again to the keystroke dynamics. And then number 45, President of the United States, came into office. And he said that, no, we are not going to allow people from certain countries to enter the US just because they are from those countries. And I said, well, hell no, I'm not going to the US before you are out of office. So then we have a few dark years in the US where PasswordsCon was being run at B-sites, but I did not attend, so I will not talk about the talks that they had there for now. 2018, Stockholm, Ricky Mondello from Apple, how iOS encourages healthy password practices. This one is really interesting. Santik and Lyngedal from a health organization with the government here in Norway, talking about implementing the fact that we will allow people never to change their password ever again. How do we actually do that in real life? Sibusiso from South Africa, he did something really cool. He took some of the most common passwords you can find online, 1, 2, 3, 4, 5, 6, and password and football and so on. And he looked for those words, if you could translate them into local languages in South Africa. And wherever he found a translation, he took that word in local language, He hashed it using MD5 with no salt, so you can have amazing cracking speeds. And then he gave those MD5 hashes to some of the best password crackers in the world. And he said, here are some incredibly easy passwords. These are among the most commonly used passwords in the world. Can you crack them? And they pretty much didn't crack any of those passwords at all, because they have been translated into languages where we don't have word lists available. Meaning, the very simple thing is, whatever you do, do not use English words in your passwords. That's sort of like a big, big no-no. Christian Brown from Google about WebAuthn and security keys. Callie Robinson from Twilio talked about authentication beyond SMS. Twilio is a very big provider of SMS and phone services. Cecilia, again, human skills for more secure behavior. How do we talk to people? How do we nudge people into doing the correct thing? Miranda talked about the users and reducing password reuse. And Marie did a really nice talk, which is, again, the closing talk, the big picture. You know, there's a world outside passwords, which I can't imagine, but there is. And she talked about that. 2019, I'm getting close now. Mats Grant, he's with the Norwegian Refugee Council. If you have any money to spare, send them to them, because they are doing amazing work all around the world in the shittiest places that you can possibly not imagine. And he said passwordless for the win. And I was like, ha, 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 ha. Okay, game on. And then Mats signed up for PasswordsCon here today. And he was like, yeah, we're not quite there yet. So Mats is going to talk a little bit about that this afternoon. Peter Meyer was back again talking even more about how to enter your password correctly from an Xbox and stuff like that. Stefan, is this really you, an empirical study on risk-based authentication in the wild? That's the next upcoming talk. Pierre talked about protecting customers against password reuse attacks in 2019. He works for a very large online gambling company, 25 million users at a time. So it's interesting, you know, it's a real world perspective. Cecilia again talked about enterprise password managers, which ones to use and what should you be considering before you select one. Pilar from 1Password talked about who are you again, verifying user access rights in an encryption-based system. She's with 1Password. She's an interesting talk. And Junaid, not here yet. Changing password policies at scale, the story of pawn passwords and K-anonymity. He's the guy who more or less did that in cooperation with Troy Hunt. Then we went online. Philip talked even more. Jim Fenton, is the future really passwordless? This is, should I say, there are no conclusions from Jim there, but again, it's a short, sweet talk. Again, what do you actually mean by passwordless? Is there a set definition of that? Pilar again talked even more about how to authenticate people that want access to 1Password in the case where they don't want to know the customers. And Ricky Mondello from Apple talked about Password Manager Resources, open source project, which you can find on this address. 2021, Leona talked about mitigating users' misconceptions about FIDO2 biometrics. Stefan, again, about FIDO2, and Christian Brand, an update on FIDO. And then finally, August last year, Mia Lansen from Norway talked about why kids couldn't care less about your password advice. She is very famous in Norway for helping young kids, teenagers and women with stalkers, harassment, online harassment, and so on. She's absolutely amazing, and she talks about, again, why your kids at home couldn't care less about your password advice. Like, as an example, why do they share their password for their Snapchat account and so on with friends and the boyfriend or girlfriend and so on. Hey, Junaid. Yeah. Jim talked about, Cecilia talked about, I know, but I have a system. Yeah, I have a system for generating passwords, and that's maybe not the best idea. Jim talked about comparing centrally and locally verified memorized secrets. This is connected to FIDO. Susan Paskey did a pretty cool talk she looks at logs. And one of the most common things that she's talked about in her talk is people will enter the password into the username field. Username field gets logged. So those logs are always of interest if you're a hacker and also if you are one of the system administrators. Look into your logs because people will enter the password in the username field. Christian again talked about passkeys, which is a new thing. And this talk from Dimitri Fouzikis in South Africa is also really, really cool because again, this focuses on passwords in other languages and other alphabets than just plain English, Latin alphabets. And there are some, for those that are really into hardcore password cracking and or forensics, that's a talk to have a look at. Last but not least, I also did an interview with Jeremy Gosney. Passwords but Make It Nihilism is available on YouTube, and he basically says that if you become the victim of a man-in-the-middle attack, does the length or complexity of your password really matter? No. If your password is stored in plaintext, does it matter if it's long and complex? No. And he listed a ton of scenarios where password length and complexity doesn't matter at all. So he basically says that you don't even have to care about length. The only thing, if there's only one thing you have to do, is to have unique passwords for every single service, so you don't become victim of password reuse attacks. And that's my summary. So what did PasswordsCon ever do for you? Well, at least it's my little contribution trying to do good in the world, and I would just say thank you all for contributing to PasswordsCon. I just connect people and I talk way too much. Thank you. And then we'll do a little less than 30 minutes break. There's coffee outside, there's tons of sugar and also some sodas without sugar here. I will also be getting some fruit. We also set up for lunch at 12:30 today. So feel free to walk around, go to the toilet, or if you have to go outside for some weird reason, you can do that as well. Okay, so next talk is from Stefan. I'm going to say it myself. He defended his PhD thesis last week. So
thank you. Thank you very much.
Buy him a beer this evening or 7. Prices in Norway are rather tough on Germans. And I will leave the rest to you, Stefan.
Yeah, thank you very much for the introduction. It's actually my 4th time at PasswordsCon. I'm giving talks, and it feels like home. Being always there, meeting the people, all a little bit nerdy about passwords and authentication. So thanks also to Per for making this happen each year. And yeah, this conference also opened a lot of doors for risk-based authentication. My name is Stefan Wiefling, and I'm from the HBRS University of Applied Sciences. And we're talking about authentication, and especially password-based authentication. I mean, they are deployed in all the websites we know, and we have a lot of them. So I'd like to ask the audience a little bit, how many passwords do you have? More than 10? Raise your hands. Okay. More than 50? Okay. Still more than 100? More than 150? How many? More than 300? Come on. Oh, okay. So we have a lot of these passwords that we need to remember, and that's also kind of like a weakness if you don't use password managers, because our brain cannot remember like 400 passwords, of course. So we need to cope with this problem, and I play guilty in that as well. We reuse passwords across websites, and it's still happening today. And attackers, of course, know that. They can take password databases stolen from the internet, just automatically enter these password combinations and username combinations on other websites. And since they're using passwords, these kind of credential stuffing attacks are quite popular among attackers. We can just take a look at some numbers that Akamai published on credential stuffing, and here you can actually see that we can expect around 1 billion attacks per day, and a lot of them actually are targeting the e-commerce sector. So each time an account is hacked, you have a financial loss involved. Still, we also have problems like phishing. I mean, it's an old topic. You trick people into revealing their passwords by on a phishing website. But still, if you take a look at the FBI statistics from last year in the cybercrime report, you can see that phishing is still the #1 threat and crime type reported in the last year. So we haven't got rid of phishing, and we need to protect our users against these type of attacks. And what is typically done here is two-factor authentication. So you're getting to a website, you enter your login credentials, then you enter a second factor that you own, and then you're in. Sounds good from a security perspective, but the reality is users tend not to use it on websites when they have the choice to. And especially big online services are struggling with this problem. When it's not like online banking, we have a different two-factor adoption rate here, especially on the big online services. The adoption rates are really, really low. And even on Twitter, they might be even lower today because they stopped using two-factor based authentication using SMS, which were like 70% of these 2.6%. So we have more than 90% of users on a website that do not have two-factor authentication enabled. And we need to protect these users somehow. And this is where risk-based authentication comes into play. So you're using your username and your password. And while you enter your login credentials, you're also submitting additional metadata that is available in the context. For example, what's your user agent, what's your IP address, what's the browser information, and so on. And in the backend, we're just estimating the risk based on previous logins and also logins of other people on the website of how likely this login attempt is a hacking attempt. And this is typically categorized into low, medium, and high risk. If you're just taking some examples here, I'm just signing in from my university using the same device I'm always using. In this case, I'm just getting signed in as always. This is different, however, if we switch to another location where I've never been before and using a device that I've never used before. And in this case, risk-based authentication is not sure if it's really us trying to sign in. You might remember some dialogues that look like that. So they ask you for an additional authentication factor, like getting an email digit code sent to your email, which you have to verify. And in this case, if you provide the correct proof, you're getting signed in to your website. And in case of an attacker, this might be different because an attacker normally does not have access to your additional authentication factor, so this would fail. And there you can also see the basic difference between classical two-factor authentication and risk-based authentication. In case of risk-based authentication, you're only asked for additional authentication when there's a higher risk involved and it's probably an attack. Risk-based authentication is recommended in the NIST Digital Identity Guidelines, and also the NCC recommends it. We also have the ACC from Australia that recommended, and we even have a presidential order in the US, which so governmental institutions in the US have also to establish risk-based authentication. So it's getting more and more important. Also, our research showed that risk-based authentication is perceived more usable than comparable to factor authentication methods. However, at the part before we did this research, we just had limited research on large online services. I mean, these have to implement it, but we don't know how it actually works on these big online services. And actually, thanks to a PasswordsCon talk I gave some years ago, this collaboration with Telenor was made possible because now we were able to analyze a lot of login data from real-world users to figure out how RBA actually works in practice. And so we had a data set collected by Telenor, privacy enhanced, that we've gotten here in this collaboration. So of more than 3 million users on a website, more than 30 million login attempts, collected over 1 year at Telenor with the feature data that was interesting here. If you see the login traffic, you can also see that there's like a structure of how people actually sign in on the website. So at specific times of the day, and also like in different months, there might be a peak of failed login attempts. Furthermore, the login structure here is the people logged in less than a month, most of them, but also daily users were quite common here. Regarding the devices, you can also see in the data that they're mostly mobile users, but also desktop users involved, which we analyzed here using the data. To analyze RBA, we focused on the Freeman algorithm, which is like the most popular and best performing algorithm on RBA that is published in the literature. It's also comparable to what we found on popular online services in previous studies. And I just like to explain it a little bit to understand how it works. First of all, we have a risk score that we calculate. So this is a number that estimates how likely it's a risky login. And we input some feature values. So for example, the IP address and the user agent of the current user that tries to sign in. We put this in and we have some fancy formula here, but it's still just a probability of how likely this user, all the users on the website have actually used that feature value here. So among all the users, and the second one that we also use is how likely this user that tries to sign in right now has used this feature before, the legitimate user. And why are we actually asking that question? Well, maybe you're still using your favorite online browser. And even if you're still the only person using Windows XP and the Internet Explorer, we don't want to lock you out of your online service. You're the legitimate user, so there you go. We know that it's you. So that's the important thing about that formula. Furthermore, we also have certain probabilities here. For example, a user might be more of a target on an online service. For example, just taking social media, the more followers you have, the more interesting you might be for someone. And also, if you're the legitimate user signing in, how often do you actually sign in? So if you're signing in from a daily basis, the risk might be lower than someone else signing in once a year or every 2 years. So this might be different. And of course, now we have that formula and we want to analyze how it actually performs against the different types of attackers in practice. And so we came with 4 different attacker models that we could analyze it against. First of all, we had a naive attacker, so this attacker just knows the login credentials and tries to sign in from somewhere in the world. Then we had a more targeted attacker, like a VPN attacker. This person uses a virtual private network to spoof the country of the victim. Then we have the next step, a targeted attacker that is also aware of the city, the browser, and the device, and tries to spoof the values here. And thanks to the data we've gotten here from the large online service, we also have a very targeted attacker. So we have verified breaches, so successful credential takeover, account takeover attempts that were successful and labeled by the Telenor team as account takeover. So you could also analyze that more further. And if you see the distributions of how these attacks are actually present in the data set, you can see that most of them are actually the credential stuffing attacks. And when it comes to more targeted attackers, these are not that distributed here. So just to have some numbers here. And the results at the end showed that actually with risk-based authentication, you can achieve low re-authentication rates in practice for legitimate users, even when you block a high number of targeted attackers. That's a result here, but let's go deeper into the results. So we just had these attackers and replayed all the login attempts on the whole data set, so to simulate how it would behave. And we had the re-authentication rate on the left side, and then we have the login history size, so how many logins have been actually conducted by these users. And then we also show up the true positive rate, so how many attackers have we actually blocked in percentage from 99.9% to 97% here shown for the naive attacker. And what is actually seen here is that the re-authentication rates decreases the more logins you have. Makes sense from there. So there might be one point when it just goes down where the login requests will decrease. Of course, this might increase with a stronger attacker, which makes sense, but still you can protect against a lot of attackers, and even targeted attacks we were able to detect with risk-based authentication. Regarding the login frequency, we also found that this has an impact on how RBA behaves, because there might be some people signing in on a daily basis versus those that sign in once a month or less than once a month. So I just calculated the re-authentication rates for daily versus less frequent users. So you can see that daily users are less asked for re-authentication than other ones. So if you have less frequently asking users, you might have to put down a little bit of the attacker protection because the values might change. So they have the same degree of re-authentication levels than for your daily users. However, this tendency is also the same one for all the attacker models. So you can see that there's a tendency for that. Login history minimization in my last talk was also something that was of interest for further research, and now we had the data to do that, because in terms of privacy and also performance issues, we should think of reducing our login history to delete some entries after a number of months, because I think no one wants to have like 10 years of login history collected about a person, so we should reduce that to some degree. So the question was, how does it actually change when we remove the login history of all the users after a certain amount of months? And what you can see, it increases the overall authentication rates the less data you keep. Makes sense, of course, because you do not have a lot of data available, but it really depends on your user basis. So if you have a daily users, you do not need to keep a lot of them, while for less frequent users, this might increase, which makes sense if seeing the data. Next topic was also the round trip time, which I also talked about last time, which can be a privacy, in terms of privacy, can be an interesting feature to look at. For example, using WebSockets, which is deployed in all the modern browsers worldwide. Once you have a connection initiated, the server can send you a ping frame. So this is a server-originated feature. And then as the client, you can respond with a pong frame. Then you just measure the time between ping and pong And there you have it, the round trip time calculated. And why is that an interesting feature? Well, you can just use it to detect whether you're inside a certain country or not. So you can detect whether you're using a VPN, because you always have delays that are introduced based on the VPN connection. And you cannot go lower than that when you're not inside the country. So you can use the time as a strong feature to detect such account takeover attempts that spoof or try to spoof the region or country using the VPN. And the data also showed that you can use the round trip time here to distinguish countries, regions, or even users. So you do not need to store the full plaintext IP address. You can replace it with the round trip time actually to still achieve strong security, usability, and privacy attributes on your RBA implementation. So this looks promising for future RBA implementations here. However, what I found while doing the analysis, you might need some optimization. The first RBA algorithm that I used with not too much data was okay for that. But as you saw in the formula before with the probabilities, you need to query a lot of databases and grab the data and estimate how likely features appear. But it takes a lot of time. I think it was 3 seconds or something until you get a result, and this is not acceptable for a good authentication. And actually you have a risk of denial of service because the longer it takes and the more concurrent users you have on your online service, the more peaks you might have. And that's what I had with my unoptimized RBA algorithm. You had a lot of users signing in concurrently at the Telenor website. And when you run that algorithm and simulate it here, you have some peaks. So the authentication time would go up until even 300 seconds or something. And yeah, this is something we should avoid. So the simple solution was to use some hash tables, so caching a lot of results, storing it in the random access memory. And by doing that, we could reduce the authentication time a lot. And it stayed to a certain level. Even if you're using all the 30 million logins, it went pretty fast at the end with the algorithm. So this is regarding the analysis of the data. And yeah, we are also very happy just to present that we did an open source solution now. So you can also now use risk-based authentication thanks to the collaboration here with Vincent Unsel, Niels Gruschka from the University of Oslo, and Luigi Loiacono also from HBRS University of Applied Sciences. Because now based on all the results that we did in the past 7 publications we did, we were now able to design an open source solution that is now ready to use in OpenStack, which is a cloud computing solution that is open source and used also by companies worldwide. The front end that you see here, the dialog that will be shown is based on what is found in real world solutions. So see my first PasswordsCon talk to see where it was based on. We use email verification via code, so this is like the state of practice that we found here, and also the generic dialog based on what all the online services agreed on back then. Regarding the verification methods, this is the second PasswordsCon talk I gave. We designed it based on what the usability studies we did. We compared several email-based verification methods and selected the one that performed best. So it's email-based verification with a 6-digit code in the email subject line and body. But still, if you like to do something else, feel free to do so. You can modify this in the plugin and add additional or different authentication methods if you like. Regarding the feature selection, this is based on also the most effective ones to identify users. So this is based on what we all did in our privacy and security studies on risk-based authentication. So the features we used here are the IP address, the user agent string, and also the round trip time. But however, you can still extend this or vary this in the plugin. So it's there, it's open, so feel free to do this. And now we come to the conclusion, and I'd just like to summarize what we found here in our first large-scale study here. We can say that risk-based authentication can achieve low re-authentication rates even when you block a lot of attackers. but however, it really depends on the user base. So if you have like people signing in daily, then you can block even more attackers. And otherwise, you might have to go down to by 2% or something to have the same reauthentication rate here available. The round-trip time is also promising to replace the IP address at the end for more privacy by still keeping the security and usability properties of risk-based authentication. And also, you can probably optimize the algorithm to make it faster on the large-scale systems, which is very important. And the best thing is we have a dataset available now, a privacy-enhanced synthesized dataset based on the Telenor data we had. So feel free to use it, the 30 million login attempts. You can just download it at riskbasedauthentication.org. And I hope you use the data and also the algorithm that we published to make RBA even better and do more research on that, because that's what I would be very interested in, hopefully the other ones as well. And you can use the open source plugin. We also have a reference implementation for risk-based authentication, which you can use with the dataset together. So this is also like a blueprint for developers to start looking into that topic. If you're interested in how to test your RBA solutions, we also have some guidance in the paper. So just take a look at that and how to do this in the future. We also have future projects that we like to focus on also regarding that topic. We like to put RBA into more open source software. We won the Open Data Impact Award last year, so we had some prize money that we put in right now to have some people working on putting it into more RBA solutions that are open source, so to increase the overall awareness of it and making it easy for everyone to do that, to protect more users worldwide. So this is the goal that we're currently working on. And also continuous authentication might be an interesting topic for research. So this is not only about verifying the login attempt right now, but also how the user that might be a little bit suspicious will behave on the online service afterwards. What are the actions and how can we actually detect an attacker while they are still in the session? So it might be a very interesting topic for the future. And yeah, let's make our users more safe and secure. I hope I could sparkle some interest in the topic. And if you got any questions, just feel free to reach out, for example, via email. I'm also on LinkedIn, all the social networks, also Mastodon, or you can read all the results in our risk-based authentication website. And now I'm very happy to answer any questions you might have. So thank you very much.
Questions?
Hi, Stephen. Yeah, thanks so much for this talk, and thanks so much for your work over the past few years on this. And yeah, and also congratulations on your PhD. Just wanted to ask, I guess, two questions. First one with the VPN detection piece. I was wondering if you had thought potentially about using the autonomous system of the network. So if someone was, for example, detecting from a like internet backbone network, something like Telia, Hurricane Electric, versus more of an infrastructure network provider versus something instead like Verizon, Liberty Global, Orange, something like that, whether that may be better to infer whether someone's potentially using a VPN. And second thing I wanted to ask about is one of the tactics in the past I've used for doing this in reverse of identifying attackers is looking at the properties of what they do in aggregate. So for instance, attackers will be more likely to potentially encounter things like rate limiting errors, client errors, and HTTP requests, server errors, things like that. I wonder if you could use that in reverse for the clients in order to, in aggregate, work out if they are less likely to be an attacker effectively because they are within the bounds of what is in aggregate properties, even though on a request-to-request basis they may be distinguishable from an attacker versus an user.
Yeah. Long questions.
Yeah, I have to remember them all. I think the second one I remember was like if you can just also detect attackers by looking and how they behave, like putting some different requests. Yeah, I think that's also something that is used to detect attackers. I haven't looked into that because the focus was more on can we proactively detect them just on how they try to sign in, but still very interesting. I think, to look into. And the first one was, I think, based on what kind of network they're actually using.
The name of the autonomous, so when the BGP system for when a network has an IP address, they will get a block, and that will be associated with an autonomous system number, and there's a name, so that will be like their Verizon, or it will be a consumer network if they are a network like potentially Liberty Global or Orange, something like that. It would be that you would instead see that they would be a consumer ISP, for instance.
Yeah. So to detect attackers, if you're able to detect attackers based on the network they're using, because some might be consumer networks and some are more industry networks, it can be actually based on the attacker models that we designed. We took some databases based on what are known attacker IP addresses. So we did not do this work on our own, but you can still, I think you can still estimate a little bit about whether you're a consumer or not if you're using like something a consumer would normally use. So you can probably use that as an additional feature also in the risk-based authentication method, or in this attacker piece that I showed in the formula. You can also add whether, if you have a very suspicious network, then you probably have a lot of IP addresses that are suspicious, or the ISPs that are suspicious. There are data sets and you can use it, but what our analysis showed, you have to use it with caution. So it really depends on the quality of the data to look into that. But it's something I would also would like to take a look at when I would design a system.
Good questions, good answers, and I love the fact that there are no yes or no questions or answers, but we also need to move on with the program. I'm bringing pizza and something to drink in the afternoon, so of course much more time to ask questions there and during our breaks. So thank you again, Stefan.
Yeah, thank you.
We can hear you, and I'll just switch to this one. And then we are ready for our next speaker. This is Max. He's also been with PasswordsCon for
8 years.
8 years. Yeah. So he's one of those that I do expect to stay with PasswordsCon for the next 10 years as well, as a minimum. I didn't mention any of Max talks from previous PasswordsCons. I had to choose, but Max does. This is me just sucking up to Max. He's done really good work, and sometimes I don't understand everything because, as you said, I don't understand math. But again, a great work. When I turned 50, almost 2 years ago, I also said that when I turned 50, and I couldn't do this because of COVID, but my biggest wish for my 50th birthday was actually to have dinner with Jim Fenton, Laurie Kramer from Carnegie Mellon University, Cormac Roll from Microsoft Research, and a few others. One of them would be Max. And of course, that would be an evening where we would only be talking passwords and digital authentication. I'm not interested in beer, football, or cars at all. So with that, I will leave it to Max, and you have to click something to get back on screen again.
Where do I have to click? I will try.
Yeah. Stop now.
Yeah, it's the HDMI. Okay.
Go.
Wonderful. Thank you very much for the introduction, Per. So my name is Max. I'm a postdoc at the Max Planck Institute for Security and Privacy in Bochum, Germany. And yeah, today it's my pleasure to present joint work with my colleagues. Philip, who is in the audience, will also talk about risk-based authentication today. Theo and Markus, which you have heard about before. And yeah, I'd like to talk about the human-centered side of things, human factors in security. And we investigated how administrators configure risk-based authentication. Okay, let's start, quickly dive in. I'd like to recap a bit because Stefan already explained all of this in far greater detail. But what you should keep in mind how risk-based authentication works is when the user tries to sign in, they do not only send a username and password to the authentication server, but also additional contextual features. And this could be the IP address, your browser, your operating system, but also the approximate location based on the IP address. And all of that is sent to something called a risk classification engine that then tries to determine how suspicious the login is. And this is risk-based authentication in a nutshell. But of course, as authentication in general and this risk-based classification engine in particular are rather complex things, and they are often outsourced. And one solution for that is an identity and access manager. We have heard about Okta and CyberArk and so on and so forth. But there are also cloud providers that offer this feature, for example, Amazon and Google. And at the very end, however, even if you use a cloud-based solution, there's one person responsible for configuring all of it, and that's, of course, the system administrator. So this talk today is about this person here configuring this risk classification engine. And yeah, we have, in one example here, we studied the Amazon Cognito service, which is offered by AWS, and they have a special adaptive authentication product, and we have a look at that, and here's what it looks like. At the first scene, it's a bit too much, a bit overwhelming, but I will guide you through this configuration. This is Amazon's Cognito's adaptive authentication interface, and it's part of their authentication solutions. And yeah, essentially it has 3 configuration options, and we will dive into these 3 a little bit more deeper. And we studied it with 28 administrators that try to configure this RBA system. So the first configuration that administrators can do is change the risk level behavior. What is meant by that? It's what you can see here. The risk classification engine outputs a risk level. It could be either low, medium, or high risk. And based on that, the administrator needs to decide what should be done. What should be done in response could either allow the login, or it could present an additional challenge, a multi-factor challenge, or it could even block the login completely so no one can sign in anymore. And yeah, that's essentially the configuration options for this main risk-based system. But there's also more, because as you can see, there are 2 different multi-factor authentication options that you can choose from. And one is called optional MFA, and the other one is called require MFA. And I could assume that all of you have the question, what is the difference? What does it mean? And the participants in our study had the very same question. So we went into the documentation of Amazon and had a look, and what they write there is that optional MFA is prompting the user to present a second factor in case they are enrolled in any. In contrast to that, there is require MFA, which enforces a second factor. And if the user is not enrolled in any, they can simply not log in anymore. So that's the difference between the 2. And then the second configuration option that is offered is when to send a notification to the legitimate user. And the interface is very simple for that. It's only a binary decision. So administrators can either send a notification or not, depending, of course, on the different risk levels. And then the final configuration option is the notification text. It can be customized in the interface. And this is the sad interface for that. And you can only see one text box here, but there are three based on whether the login is allowed, there is a challenge, or it's blocked. And they can use certain placeholders. You can see a placeholder here in yellow where you can change, where it's automatically filled in, and it presents the time, the device, the operating system, city and country automatically for the administrator. And at the bottom of the text, there's only two hyperlinks, two hyperlinks, and by default, it's called one-click link invalid and one-click link valid, which means it's a one-time link you can visit to tell the system whether it was you who just signed in, or you do not recognize the sign-in, and thus you report it to the system as being a malicious sign-in. Those are the two hyperlinks at the bottom of the notification. And now to our user study. So we did a user study with 28 administrators, and they were all given the same fictional scenario. And it read like, please imagine you are the system administrator of the Media Shop Corporation, where you administrate the online shop dresscode.com that we just made up. And the task in the user study was to configure this risk-based authentication system, which is it's a mock-up of the Amazon Cognito interface. So it's a real-world RBA system that we study here. And the study consisted of 3 parts. In the first part, administrators were asked to configure the system. And then in the second part, we had a questionnaire prepared where we asked some question about the usability of the system. And at the very end, there was an interview study where we conducted semi-structured interviews and asked the administrators about their experience with the system and like the roadblockers, the reasoning behind their configuration and what went good and what went bad. And overall, the entire study took 45 minutes. We studied 28 administrators, which are not that easy to recruit, I can tell you. And 9 of them had less than 10 years of experience, 10 between 10 and 15 years, and we even found 9 administrators that had more than 15 years of experience. So they were quite experienced when they did this study. And now the more exciting part of this talk, the results. So here you can see on the left-hand side the different risk levels, and the small bars you can see here are the defaults. This is the value that Amazon suggests to use for this risk level. So for a low-risk login, it says just allow the login, everything is fine. And for a medium and high-risk login, they suggest to use the optional MFA, so present the user with a multi-factor challenge in case they are enrolled in any. And here's the result. So you can see administrators deviated from the default quite a bit. So we observed the tendency to spice up the defaults. That's something that is inherent in every administrator. If there is a slider, move it to the right, right? Make it more secure. So we can see that for the low risk value, 19 participants increased the value. For medium risk, 23. And for high risk, almost everyone, 27 administrators, only 1 kept the default value. Increased the slider, increased the setting to make it more secure. And interestingly, for the high-risk logins, even 10 administrators chose to block the login completely. But please keep our scenario in mind. We are not protecting an organization here. We are protecting a website that's called dresscode.com, right? It's a user-facing website. So what are the themes that we observed and the reasoning behind it? So we found that administrators try to spice up the defaults for whatever reason. And when we ask, hey, why have you chosen to spice up the defaults? 14 of them answered, it's easy because multi-factor authentication is very easy to use. Okay. And 6 of them said, well, I have chosen this configuration because I have seen it in the past with other systems, and this is what I would expect. This is what I have seen in the past. So I copied the configuration and configured it the way I have seen it before. And only 4 administrators out of 28 had the user in mind when they configured the system. And that's a bit sad. There were 2 quotes that I want to share. So here's one participant that said, I chose to require MFA because from my experience, users don't find it that hard to use, and it really increases the security. Yeah? So the second part is definitely true, it increases the security. The first part depends on the system. And then there was another participant that was a little bit more cautious, and this participant said, well, blocking is of course very invasive, and I mean I would bounce our customer and we don't want that. Maybe they go to a competitor. So here's the user in mind, and making a profit is more important than security. And then when we ask what difficulties they encounter, what were the problems they had, then most participants said, well, I'm puzzled about the computation of the risk levels, so I don't understand how they are calculated, and that's why I'm having problems configuring it. 6 were puzzled about the phrase optional MFA. What does it mean, right? You can only find it in the documentation, which we provided. And then, of course, there were other problems like missing descriptions and the confusion about the risk levels. What does low risk, medium risk, high risk even mean? Stuff like that. And some of them even said they are missing configuration options. So one configuration option that was often mentioned is they wanted to configure which multi-factor challenge is presented. So is it a one-time password or is it a security key, just as an example? And interestingly, 15 administrators clicked on the help link, and 2 of them said they even used Google to configure the system. Okay, moving on to the next result. When to send the notification. So by default, the default value here is to notify independent of the risk level. So every time there is a login, Amazon suggests to send an email. Okay, and here's what our administrators did. They mostly haven't touched it. So there are a few that changed the setting to not notify. Interestingly, there's one participant that turned everything upside down and said, well, if it is a high-risk login, I can be certain it's an attack. Why should I notify the user? Okay, and when we asked for their reasoning behind it, so few of them changed the setting at all, and those who did, they said, well, there's something called notification fatigue. If you notify the user every single time, it's a problem. And one was a bit confused or a bit concerned about that the attacker could fool the system, and what is meant by that. So the first quote here that I want to share is who said, if you get bombarded with login notifications, you get annoyed. I agree to that. Why would you look at it unless you make it screaming, right? So the notification should only be sent if it's really important. If it is just a regular low-risk login, then don't send a notification. And the other participant had a different opinion and was concerned about fooling the system. And they said, I don't know if I'm giving away information. If I have a hijacked account and the attacker can click, yes, it's really me, how does it go then? That's an interesting question. So remember, there is this hyperlink at the bottom, and there I can report that this login was me, everything is legit. But what happens if the account is hijacked and the attacker clicks this link? Right? And there is very related to this, there's a talk by Google. It's a few years old, already at Usenix 2018. And there they say, well, they use this login notification email as yet another factor, contextual factor, because if someone signs into the account and deletes the notification immediately, they will automatically increase the risk, right? Because this is behavior an attacker would do. They sign in and delete this email so the legitimate user will not see it. So that's related to this quote from this administrator. Okay, moving on. The final result is the notification text. And here you can see the allow notification. We observed an unrecognized sign-in to your account with this information. Then it shows the time, device, and location, and then the 2 hyperlinks. Very boring. And how have the administrators opted to change it? Well, first of all, the majority changed it. 16 administrators opted to change it. And most of them were concerned about adding more details, because for a technical person, more technical details are always great, like having an event ID and super boring stuff for a user. But yeah, the majority of them wanted to add technical details. Some of them were concerned about changing the wording to make it more understandable, which is a good thing. And then 3 of them wanted to add more context. Why am I receiving this email? What is this all about? 3 were concerned about phishing, because you can also, if the email includes a hyperlink, you can potentially abuse it for phishing. And 2 administrators, this is very nerdy, were concerned about the precision of the geolocation, because the location is derived from the IP address, and you know it's not always accurate. So they wanted to put the word approximate location, approximate in front of the location, to make the email more trustworthy, I would say. Okay, so here are 2 more quotes. One participant said, I'm trying to make it understandable, which can be a challenge, I agree to that. So in real life, I probably would have spent more time with the email and also worked with the communications people and tested the email, which is a nice thing. And the other one said, not to touch the default text, and this is a very administrator-like response. I know if you put software somewhere and tinker with it, it will break by the 3rd update at the latest, especially when working with placeholders. Things go wrong so easily, right? So they chose not to change the text, because if you do, it will break. That's the main finding. Okay. So let's summarize what we have found in our study. We learned about the power of defaults. So meaning administrators struggled with deciding which risk behavior is a reasonable one. And thus we recommend that the defaults that are presented by Amazon should be based on common scenarios. Like in our scenario, it was online shopping, dresscode.com. And you should have a drop down where you can choose this particular behavior and make suggest reasonable defaults. This would make the entire configuration process easier and probably also better for the user. The other thing that we found was that it's super important to define important terms and technical lingo, especially like phrases that are open to interpretation. For example, what does low risk mean? What is optional MFA? What is block? Does block mean I can never log in again, or can I never log in for the next 2 hours, or what does block mean? It needs to be defined. And again, we recommended Amazon to update the documentation and help pages to give examples and so on and so forth. And then we found this urge to understand, so administrators really wanted to have insights into the risk calculation, how the engine works, which factors are considered, and they claim if they have this background knowledge, then the decision-making process would be easier and their suggestions would be more reasonable. And interestingly, related to that, there is even a 4th risk level. It's not only low, medium, and high, but Amazon also supports no risk. But it's not in the documentation. In the documentation, very deeply, we have searched, Philip and I have searched for it yesterday. There's a screenshot, and only in the screenshot you can see there are 4 risk levels, not 3, and there's also no risk. But it's not present in the interface, so yeah, it's understandable that administrators will misconfigure the system at this point. And finally, yeah, the impact on the user is often not considered. Only those administrators that had like users in mind from the beginning chose a configuration that was reasonable for this scenario. And we like to change this. We like to suggest that Amazon changes their interface and, for example, introduces a simulation where the administrator can experience themselves what does it mean if I click on optional MFA here, so they see what happens. And if you read the documentation carefully, Amazon even suggests that there is something called an audit mode, and you should enable this audit mode for 2 weeks. So this audit mode will not enforce the configuration, but simply after 2 weeks report to the administrator what the potential impact of this configuration means for their use case, so they know how many logins would have been blocked if it would be enabled. And yeah, finally, across all participants, we saw a lack of consensus when it comes to the notification text. This is a difficult and hard topic, and that's why Philip is going to talk about it in more detail later. Yeah, and with this, I'm done with the presentation. Very happy to answer your questions. Thank you.
Questions for Max? Yes, sir.
Did the age matter?
Did the age matter? Good question. I think with 28 participants, we have no statistical significant difference found in our data set. I could be wrong, Philip, but no, right? No, I think the age didn't matter but our sample was so small that it's hard to tell. Yeah. Yeah.
In your data set, did you also classify administrators from the background, like what kind of company they come from, the industry? Like I'm assuming banking industry will
has a different
be
background.
That have all this libraries.
Yeah. I think the answer here is the same as for the age. For that, our study was too small to tell anything. Yeah. Yes?
Can you say something about which countries these assessments are from?
I could. If I would be prepared. So that's true for all what I presented today. It's a paper. It's open access. You can. Okay, the browser doesn't work. It's open, and I'm not on Wi-Fi anyway. It's open access, and you can read the entire thing. It's 15 pages, and there you can also find a demographics table. But Philip, have you reported where the administrators are from?
Yes, so we've got 17 from Germany, 6 from the US, and then 5 from other countries.
So the majority was German, yeah.
You might want to repeat things for the remote audience.
Okay. The result is the majority of the recruited administrators were from Germany and the US. Does this answer the question? And there's the paper is online. You can find it. I can share a link. I share a link on Twitter. Yeah.
Yeah.
Okay.
More questions?
I was one, but I don't recall what I answered.
Well, then again, thank you, Max.
Okay.
And we will do our short 10-minute before our next speaker, Philip. Sound is on, and recording is on, and streaming is on, and it's time for Philip. Something is broken in the state of California, understanding users' interaction with login notifications. And I'm looking forward to all the talks, including this one, so take it away, Philip.
Yeah, thank you so much. And yeah, today's talk is again about risk-based authentication, and we'll see how Hamlet sitting at the beach in California comes into play. And we're going to talk about the notifications that Max was just talking about at the very end, and look into a bit more detail on how we could actually design them in a way that users understand them in a better way, and how they are currently also perceived by the users. So I'm going to skip the introduction, so yet another introduction of risk-based authentication. I think you got the concept. So based on risk, decide how to interact with the user. But I want to show a login notification so we're all on the same page here and know what we're talking about. I picked an example from LinkedIn. You might have seen it. And it tells me, well, we noticed you recently signed into your login account from a new device. And in order to finish login, please input the code that we've just sent to you. And then down here, there's some information about the actual login. So the placeholders that Max just showed you. So here's the date, and then the operating system, browser, and an approximate location. And then down here at the very end, there's also this information or with the instructions on how to behave if this is a login that I do not recognize. And it says me here, change your password right away. And there's also a link associated with it, so it's easier for me as a user deciding to change my password, actually doing that. And so, yeah, these are the notifications that we're going to have a look at in the, let's say next 15 to 20 minutes, and see how users perceive them and how they also react in regard to them. If those notifications are sent, there are two possible cases and 4 outcomes at the very end. And the first case is, well, it's actually me signing in. I have my password, I have my username, I'm signing in, and I received this notification for a login that I just initiated. That is the easy and probably also the case which happens most of the time. However, there's also the second case, and here we are assuming that an attacker got hold of the password, for example, through a data breach, a man-in-the-middle attack, or whatever you name it, and now the attacker is actually trying to log in with that username-password combination, and I'm the one receiving a login notification for a login I did not initiate. So 2 cases, and what are the outcomes here? The first outcome on the left-hand side, I'm the one who signed in, and I understand that, and yeah, I know it's me, so I can relax because there's nothing else to do for me. Just ignore the notification, delete it, I'm fine with that. The second case, however, and that is the case that we do not want in this case, is the one where the user freaks out and has no idea about this notification. This might be, for example, because the user doesn't understand what this notification is telling them, or also because there's, for example, like a time delay, and I received this notifications minutes or hours after I actually signed in, and then I don't have a connection to it and can't understand what actually happened at that point. So this might be an issue here. For the second case, the good thing or the bad thing as well would be to relax here and say, well, it was me logging in, although it was not me logging in, because I just think, well, yeah, I received those notifications all the time, might have been, I don't know, whatever login I initiated yesterday that I'm right now receiving a notification to. And then, again, the good case here is, so it's really upside down in comparison to the first case, freaking out about a login that I did not initiate and actually taking the appropriate measures in order to get the attacker out of my account, so changing the password, activating two-factor authentication, all sorts of things at that point. So these are the cases that we want to cover in our study and that we wanted to analyze. How did we do that? Well, first of all, we tried to derive a representative notification, and we did that based on more than 60 real-world notifications that we collected as the, so to say, beginning of our study. One of them is the one that I just showed you, for example, so LinkedIn. So quite an extensive email with details there at the very bottom, so I can really decide for me as a, let's say, technical user, what is happening here. Then there's Pinterest. So a shorter email, so also some information there, also information about the device that was used, but nothing else, for example. But then there's like also short information. If it was me logging in, then you're good to go. And then again, some extensive information on what to do if it was not me logging in. So again, you can see quite some differences here. And then there's also a third example that I brought to you today, which is from GitHub. Well, I might assume, yeah, GitHub, technical community. So you can see that in mail here as well. It's very down to the actual details, but for example, also no technical details. So it's just informing me about login, but there's no information about the login included in this email whatsoever. And after this analysis, we ended up with this huge table. So you can see dots and filled out dots here. And this is the ground truth for our analysis. And this one is what we used for our study in order to derive an actual representative notification. And if I say derive, we essentially always picked the majority. So if the majority of services included the browser, that's what we included as well. And the notification that came out of this is this very notification here. So we have the subject here telling the user about what happened. So we noticed a new sign into your account. And this is what the majority of services do, include the city, include the country, the date, year, and also the time of the day, and then also the browser and the operating system. And then also 2 instructions. So for the legit case, if this was you, you're good to go, nothing else for you to do. And then if it wasn't you, please change your password right away to a secure account. And also the majority of services do include a link in their email to facilitate the password change for the user. So this is the notification that we sent to our actual participants in the study. But how did we do that in actual detail? Well, we used a distractor task and observed the actual behavior. The distractor task was necessary in order to shift the focus away for the user from the notification. Because if we would have told them, well, we're going to send you a login notification and please behave as you always do, it wouldn't work, of course. And so in addition to the mental rotation test that we did, we sent them the actual notification, and then at the third step, we actually observed the behavior. The mental rotation test, just to get you an idea of what it is, it consists of 2 pictures. And so it's either images which are the same. So this one is just tilted by 90 degrees, but it's the same. And this one is not identical because you can shift the one on the left-hand side and end up with the one on the right-hand side because it's 2 different objects. So it's a compelling mental test for users that we can tell them about. And we told them, this is what we are actually studying. So please, come to our service, do that, and behave as normal as you would do. And we didn't tell them about the actual login notification. So let's go into a bit more detail on the actual notification. And now California comes into play. The good notification here on the left-hand side is for those users where we said, okay, we're going to send you, or you are part of the group where we're going to send you login notification for your actual login. So for example, it would be, for me, it would be Bergen in Norway now, today's date, and also the operating system and browser that I'm actually using when I'm logging into a service. However, and now California comes into play here, California would be the notification that we would send to participants if they have been part of our malicious group. And California was picked because we conducted the study in America, and we would assume that an attacker tries to increase their chances by simply thinking about statistical chances. And the state in the US with the highest population, so the highest chances for an attacker to be correct, is California. The browser with the highest population or the highest amount of users in the US is the Chrome browser. And the operating system with, again, the highest amount of users in the States is Windows. So this is what a statistical attacker would use in order to increase the chances of actually, getting the right user information and making it harder for the actual user to decide whether the login was a legit one or a malicious one. Okay, and now into the actual method that we used. So there were 3 stages involved and 2 treatments. So the 2 treatments are the one that I just showed you, so legit and malicious. And this was our official story. We want to analyze the changes in spatial reasoning ability over time, so please come to our service, and in the first stage, create an account, do the test once, and because we want to analyze the changes, please come back after 2 weeks, log in, do the test a second time, and then after a final week, please come in a third time and do the test a third time, and then we're actually able to analyze your changes. This is what we told participants at the very beginning, and this is what the service that they actually signed up to. However, the unofficial story was a bit different. There were 3 stages, and the first stage was actually like we described it to our participants, so they created an account and they did the test the first time. But then it was different, so for the ones who were associated with the legit group, so the ones that actually got a notification about their own login, were re-invited after 2 weeks. They logged in. Because they logged in, they received a login notification, and they completed the test a second time. Then there were the ones who were already invited, or not invited, but they received a fake notification, so the one from California after 1 week, although they expected to be re-invited after 2 weeks. So there was no login from them, there was just a login to their account. They definitely did not initiate. And then, in order to give participants time to actually react to the email, might have been the case that they were not using their computer at that time, might have been the case that they didn't want to reply to the email or react to the email. So that's why for both groups we waited for 3 days, because finally re-inviting them to the third stage, and after the login telling them about what we actually studied, debriefed them, so complied with all the ethical requirements that we had due to the distractor task, and then we actually also answer or asks them about their behavior, why they changed their password, for example, why they didn't change their password, and also all sorts of different interactions and things regarded to the login notification. All right, now on to the interesting stuff, the stuff that you are here for today. How do users actually react to those login notifications? So again, we have our 2 groups here. So the ones that received a login for their actual login, and then the ones who received a malicious email. And for the legit group, it was fine. None of them changed their password. So 100% of them were just, reading the email but didn't react to it. However, for the malicious group, it was a bit different. 80% did not change their passwords, and just 20% or 21% actually did. So this was, in contrast to the legit case, a bit unfortunate and something we did not expect to that extent. And that's why we also asked them about why they behaved the way. And for the legit group, it was pretty straightforward. So the majority, so the ones in green here are the ones that said, well, it was me logging in, and that's why I didn't react to it, because why would I react to an email that is informing me about my own login? However, there are also 20% over here who said, well, actually I can't remember seeing this notification. And this is okay for this case here, but you may already get the idea what it happens here for the second group. But we're fine, at least for the legit group here. And then also some other responses. So 11% said it was a more or less spontaneous reaction. So those are the ones saying, received a notification, deleted it. Why would I care about it? And then also the ones over here, so they don't understand. This is a group of participants that, said they had no idea what this notification was telling them. And that brings us to an interesting aspect here. I was telling you about like technical details, and like I assume all of you here today in the group do understand those emails, but there's quite a high number of users who actually don't understand this notification and were actually telling us, well, yes, I received it, I remember seeing it, I remember reading it, but what should I do with it? So it's not as straightforward as you might assume. And now on to the malicious group. Here, 24% changed the password, and you might get it. All of them said, well, I changed it because it was not me logging in. So the reaction that we would expect, they receive a notification, don't have a context for the email, don't associate a login, they initiated themselves with it, and that's why they went ahead and actually changed the password. For the ones who did not change the password, was a bit different. It was quite a diverse sample here. So again, 22% are the ones who can't remember seeing the notification and said, yeah, if there's no notification, why would I react to it? I can tell you that we tracked whether this email was opened. And there are quite a few users who definitely saw the email where the tracking pixel was initiated, who can't remember seeing the notifications. And this brings us to the fatigue, to the number of emails which are in our inboxes nowadays, dozens of them. Yeah, one email can slip through easily, and this is probably what happened here as well for many participants. And then there's again the spontaneous group, the ones who said, yeah, saw it, read it, deleted it. Spontaneous reaction. Okay for the first group, not okay for the second group. Very unfortunate reaction here. And then 12% who said that was phishing, suspicious email, a link with an email, a link within an email asking me to change my password. Good one. Won't do it. Why would I do it? And that makes also perfect sense. We told users for ages and ages, if there's a link in the email, don't click it. And if it says change your password, definitely do not click it. And but for login notifications, we're actually doing that. And we're doing that with a good intention. We're doing that in order to, as I said, facilitate the login. But in this case, it really doesn't work out. And this brings us back to, yeah, we tell users to do one thing, and at one point we're telling them the other thing. And yeah, what should users do? So we're really in a trouble here, and yeah, because it doesn't help us at that point. 9%, very interesting group. It was me logging in. They definitely did not log into the account, but this is potentially a group that is associated to the ones who actually don't understand what this notification is telling them. So yeah, we're bombarding them with those emails. Many services sent them for every single login. So throughout our initial analysis, we also had services that really sent those notifications for every single login. If I log in now and if I log in within the next minute as well, they will send me 2 login notifications for my logins. So yeah, this really doesn't help here. And fatigue are users which especially said and highlighted that they get bombarded with those emails and that they don't care about them anymore. Very unfortunate situation. And then unsure are actually users who, yeah, comment to or comparable to the suspicious email, but with a bit more unsureness about what they would actually do with those notifications. So yeah, to sum it up again, it's quite a diverse sample here, and it's not as easy to figure out how we can help those 80% of users who reacted in a way that we wouldn't expect them to react to those notifications. All right, and now on to some final recommendations and also avoidable pitfalls. I want to start with the avoidable pitfalls, and that brings us back to our initial analysis. And we had many, many examples where I said, well, how can service providers send those emails? And one example, for example, we've got someone here who used to live in France. There you are. You as well?
Yeah, I'm French.
Okay, perfect. Yeah. Yeah, so this notification was sent to someone in Paris, and next to it is the state, so Ile-de-France, is that correct? Yeah, thank you. And yeah, but it's a French accent, and this email just doesn't show this accent correctly. You have to assume that users are coming from all over the world. You cannot just test the email with someone from yeah, let's say Bergen, and you're fine with that because, yeah, if you're having a company which serves people all over the world, then you should definitely test it with all potential edge cases and not just the easy ones, so to say. And that brings us back to phishing. So if I see an email just like that, asking me to change my password, I would be very, very careful here. Second example, yes, it's a great thing to highlight that, but then make sure that it really does work the way that you intended it to do. Again, brings us back to the phishing and the suspiciousness of such emails. Look out and test your emails carefully and with all different browsers. So we tested that with different browsers, different email clients. It really was not parsed correctly. And then a final example here. including all the information that you have might be a good idea. If you don't have any information, yes, for us, I do get that they weren't able to derive any information about the browser here. I wouldn't expect like 95% of users outside of this room to actually understand what was happening here. So if you do not have information, then why would you dare of including a browser tag there? Just prepare different emails, for example. If you have the information, if you include it. If you don't have the information, then don't dare of telling the user that you weren't able to derive it. And again, also an interesting aspect here, IP addresses. I'll leave that for discussion if that is something that you would include in those emails. In our study, we found different reactions to it. Some were positive, some were negative. All right, now on to the final recommendations. One of them is simplify parsing. 75 of our participants said that they are actually paying attention to the subject. Research from Stefan also showed that the subject can be used to facilitate the parsing of an email. And this one here on the left-hand side is from Tumblr. You wouldn't know it if I wouldn't have written it next to it, because the subject is really such a generic subject that you have no idea what this notification is telling you about just by reading the subject. However, the one from Twitter on the right-hand side is better. It's doing a great job in telling what has actually happened. Well, there's a new login, and it's also included some information already telling me that it was this and this browser on this and that operating system. So users pay attention to it. Why wouldn't you use it in order to already inform them about what is actually happening and not just giving them some generic information that they could and potentially see multiple times a day? The second one, create context and be precise. Many participants, as I said, didn't understand why the notification was sent. And for example, many services use the word unusual login. Yeah, what is unusual? So unusual, does that mean the location is strange? Does it mean the device has not been seen before? So use something like this, log in from a previously unseen device. That immediately tells me what to look out for. If I cannot recognize this device, then this is potentially something which I should look into more detail. However, if the location is fine, then I can more or less not look at the location at all, because that's something that is usual. Finally, provide all necessary information. And with that, I mean such simple information as telling the user, if this was you logging in, then you can ignore this notification. However, 36%, so 1 in 3 emails did not include any information about that at all. And why should users, or where should users get this information from, how to react in response to those notifications if we're not telling them? Yes, again, we are here in the room and we probably know if this is a login that I receive for a notification, then I can ignore it. But how should users know if we're not telling them about this? And it brings us back to the initial Homer Simpson. They will freak out about a login notification if they have no idea how to respond to it. All right, this brings me to the final slide. All on here again, that was the notification that we studied. This was the reaction to it. Those are our recommendations. And now I'm very happy to take any questions you might have. Thank you. I'm starting on the left-hand side, yeah.
You mentioned about the IP address being not particularly obvious to people, and it's supposed to be aided by the location, but as you know, the location sometimes is hilariously wrong because IP addresses are being resolved around and so on. So what do you think about using like the who is information, as in like who is actually owning this IP address right now, which might be more up to date than the GeoIP database? Because yeah, it might tell me that there is a login to my account from Bochum in Germany, but maybe it was really me, just wrong location. Whereas if it says it's my ISP, then I'm reassured.
Yeah, very good point. Short answer is we haven't looked into that. My personal opinion is that it's definitely worth testing it. So because people probably know what their internet service provider is because they at one point have to have a contract with it. On the other hand, if I'm not the one who closed the contract with them, probably also hard to derive or to use that as some useful information. But it's definitely worthwhile looking into it, yeah. Yeah, Jim?
This is maybe ascribing more sophistication to your users than you actually had, but so often when you have a link in an email, it's actually a link to some analytics site because they want to measure click rates and all of that sort of thing. So you can't really tell where it's actually going. What kind of a link was in the emails for the, click to change your password? Could they tell that it was actually going to the right place, or was it an analytics link?
In our email, you mean?
Yeah.
Yeah, it was simply the spatial reasoning ability dot.
Okay, it went directly.
Yeah, slash change password. Yeah.
I'm particularly interested about the 12% and the 9% and the malicious ones who didn't change their password. So 12% said it looks suspicious.
Yeah.
Do you have any metrics on how many of them actually generated a random password and put it in the key pass? Because for me, I generate random passwords for low interest sites, right?
Yeah.
And I put it in the password manager. If it gets compromised, I'm sure it wasn't something bad, and I'm sure it's random. So maybe that's why.
That could be one potential explanation for that. We do have this data. I don't have it in my mind right now, but I can definitely look it up and get back to you with those details. Yeah.
And the second question is the 9%.
Yeah.
How many users used your spatial reasoning study from California?
That's a good point. The hit rate was quite high there. I can tell you that there are some users in this group where at least some information was correct, but I can tell you that there were also some where there was like no hit at all. So users from New York with a different browser that they logged in. But that's a great point that you're bringing up there. Actually, we didn't expect the hit rate to be such important, because at least one information was like correct in 30% of the time, and this makes it very hard for users. Yeah.
Were they able to change the password without following the link in that email?
Yeah, they could also just go to the website.
Did you measure whether or not they changed their password like later on?
After those 3 days, you mean? So we probably have the data, but we didn't include it in at that point, because we said, okay, within 3 days. And that also brings us to the reaction time, so to say. And questions, in my personal opinion, the overall existence of those emails. Because if you don't react within like minutes, an attacker is already done. So why would you dare informing them? I think you were first and then you second, yeah.
Yeah, so really cool one. Do you get any idea of, like how these emails are classified by the email client, so that this actually has any impact on like people even opening? Because, like for Gmail, for me personally, I tend to ignore a lot of emails that go under the updates tab. So is this something you also noticed from this study?
So you mean the value of the notification for the users, or?
Like how the email client classifies it.
Okay, so we did test that for all the major browsers and also service providers for email, so Gmail, Microsoft, etc. When we tested it, none of them was classified as malicious, so they all showed them correctly, and so at least from our insight that we got, there's no indicator that our emails were actually suspicious.
But in terms of like where the email actually goes, so like if it goes under the updates tab or the primary tab for Gmail, for example.
Okay. Yeah, no information about that, so that's a bit unfortunate, yeah.
Yeah, there was so many good answers here. One thing that came to mind is that was this study limited to email as means of communication, or did you also include other means of communication?
In this case, it was just limited to email. So there's work that we want to do with other notifications. So for example, SMS is also used for that services. Amazon, for example, does that. And that's still to investigate it, yeah.
That's a secondary part of the question.
Yeah, klar.
Celia was also touching the same topic, because when you have those who would deem that the email was suspicious looking and still click the link, that could be a flag to raise. The other ones who felt that that was malicious, but then logged on to the service in a normal fashion and then went in to use the in-app specific
Change method, yeah.
password thing, that could be a good indicator.
Yeah.
Do you have any data on that part?
Yeah, on those details, we could definitely do that correlation there. I don't know it from my head, unfortunately. So that's something that I can look up within a second and tell you afterwards, please. Yeah, definitely.
And just to add to that, he already put it better than I could, but I wanted to suggest maybe that the people who don't know how important it is in general. Maybe it's me in my security bubble or like a minority of people, but I know that since we have to, sit through all these phishing defense trainings and so on, where they always say do not ever click on a link in an email, then later on the InfoSec department tells you, your password is expired, or here's another mandatory training, click here. And so there is more and more people who try to make a point by reporting those emails as phishing or any other way suspicious. So it could be those.
Mm-hmm. Yeah, it could be as well. So although this was limited to, so we also had a look at the emails, and they usually look like private emails. So we don't expect like, that making a very high impact, but it's of course a variant because users are taught that way, and might have influenced the direction there. Absolutely.
So if you're a student and you haven't finished your work yet, or if you're a professor, postdoc, anything, looking for more projects, I really hope that even this far into the conference, you might have gotten some ideas, and there will be more. I'm going to cut you off now, so thank you again to Philip.
Audio, audio, audio. Does the sound work?
Okay, so last talk before lunch. Absolutely no pressure for Jim at all. Jim has also been with PasswordsCon many times before, and I've said before, and I will say again, I never disagree with Jim. I just argue to keep conversation going.
And it's always fun when we do that.
And no, Jim was one of those that I wanted to have dinner with when I turned 50. I couldn't do that. But as a replacement, I have texted him on Signal and like, hey, and that's me sitting at home because Jim is in California and I'm here in Bergen, so obviously there's a time difference. And at like 10, 11 in the evening on a Friday for me, sending a message to Jim on Signal and say, hey, are you available for a quick 5-minute chat, which means like an hour or half? You know, those are, I've had some great conversations with Jim like that, and my girlfriend just doesn't understand why I think it is a pleasure talking to Jim in California about passwords, but it actually is. So, with no further ado, Jim.
All right, thank you. Yeah, a little intimidated about coming after something is rotten in the state of California, but now I understand. So thanks. I'm one of several editors of the NIST authentication guidelines. Since we're not a U.S. audience, NIST, National Institute of Standards and Technology, is the standards organization for the U.S. federal government. It's part of the Department of Commerce. And so, they do everything from very accurate time measurements and broadcasts, standard distances. They do all kinds of interesting, very basic physics work. And they even produce little jars of standard peanut butter. In any case, one of the things that they do is they do standards for a number of computer cybersecurity related topics. And amongst those is authentication, and this set of guidelines has to do with several pieces. And I'm probably getting ahead of myself here. I'll get to the structure of the document here. I should explain, I'm a consultant for NIST. So everything that I say here is Jim Fenton speaking, not the U.S. federal government speaking. And if sometimes I use the term "we" to describe NIST, and that's just because they make me very welcome working with them. So you shouldn't interpret "we" as meaning that I'm representing the government at all. And this document that I'm talking about is a preview draft that we sent out at the end of last year, and have been accepting comments on. There are a lot of things that are still in flux. In fact, just about everything is still in flux. So I'll be kind of talking about kind of the major changes here, but nothing is final. So we're in the midst of a transition right now. So Special Publication 800-63 is the standard that U.S. government agencies are expected to follow with respect to identity proofing, authentication, and federation. Identity proofing, of course, being the association of a real-world person with an online account. Authentication we all know about, and federation being if you're doing authentication on behalf of another entity and passing an assertion to that entity in lieu of having them do the authentication directly. Although it's used by the federal government, it's also used just kind of on a voluntary basis by a lot of other both international and U.S. organizations that like what the document has to say. So this document was put out in June 2017. It's had a couple of errata updates since then. But like all of these things, technology moves on, threats move on. We get some better ideas, and So we do an update every few years. And so what's going on right now is we sent out an initial call for comments a couple of years ago, and that resulted in a public draft that came out in December, and we've been collecting comments on that. Structurally, if you're familiar with the previous version, it was a huge departure from earlier versions. This one, at least structurally, is very much the same, although a lot of the details inside will change. We have gotten a lot of comments. We got something like 116 different submissions of comments, and we've broken those up into GitHub issues. We have an internal repository that we're using to track these, and we have something like 3,800 individual issues now created. It's crazy when you get that many issues that GitHub starts to list them in number of K issues. Something I hadn't seen before. So with respect to the authentication piece, 63B, 777 issues were created. And so this will take a while. We're running through them. We've done, I'm like maybe 2/3 of the way through with kind of the initial triage step at this point, and I have a NIST colleague that I'm working with that kind of we dual team a lot of these things, and sort of if he agrees with me, then we can go on and agree on the adjudication, and sometimes it results in an interesting conversation, kind of like the ones that I have with Per. So listed in the document, there's a kind of a change log there. These are the kind of the major areas of change in 863B-4. We've I don't need to read these, but we've got new ways of describing phishing resistance. Activation factors are a big new area that we've kind of really blown up the structure of how we're describing multi-factor authentication for multi-factor authenticators there. And external authenticators is an all new thing. Biometrics, largely, this is kind of a specialty area. This is an area that I really lean on. NIST has some really good subject matter experts on biometrics, and so lean on them a lot. We've increased, and this is largely sort of a technology thing, increased the false match rate requirement from 1 in 1,000 to 1 in 10,000, just because the sensors and the technology is getting better. But remember that that's not it's not going to always be 1 in 10,000. That's a so-called zero effort attack. That's like if Per comes over and puts his fingerprint on my fingerprint reader, what's the probability that that's going to succeed? If he was really trying and he had a copy of my fingerprint and maybe one of these rubber finger things that simulates my fingerprint, then that's a different story entirely. So 1 in 10,000 in this case maybe sounds a little bit more secure than it might be for a determined attacker. A new area that we're very focused on, and this has a lot to do with kind of the overall focus of the Biden administration, is providing equity to different demographic groups. So we want to make sure that people, and this probably comes more into role with facial recognition than it does for some of the other modalities, but we want to make sure that, for example, Black people or Asian people do not have more trouble authenticating just because of that. And so NIST has been doing some really good work. They have a group called the Facial Recognition Virtual Team that has been doing all sorts of testing with pictures of different demographics. They work with industry and get vendors to test their algorithms with all of these different picture sets, and really pretty interesting group. So if you have an interest in that area, catch me afterwards, and I can give you a pointer to where to find the virtual team. They have a good mailing list and a lot of online resources that you can use if you work in that area. So phishing resistance, as one of the earlier speakers said, is like a huge attack area. And as a result of that, the U.S. federal government has introduced some new requirements, and I'll talk into that, having to do with phishing resistance. One of the big changes that we made, for starters, was it used to be described as verifier impersonation resistance, and that was a very technically precise term, just because phishing, I mean, there were all sorts of, gee, do you mean phishing, or I mean, there's farming and there's smishing and all of those kinds of things. We wanted to include all of those things, and so we said, okay, we're going to call it verifier impersonation resistance. Well, it's a terrible term because nobody understood what we were talking about, and this is a perfect example of why you do not want me to do your product marketing. So anyhow, we had in the previous draft, or in the previous version of the specification, one method of phishing resistance, which we're now calling channel binding. And basically it's tying, in general for phishing resistance, you want to tie the authenticator output to something having to do with the verifier. So with channel binding, you're actually tying it to the TLS connection. There's session secrets that are generated as part of creating the TLS connection. And with channel binding, you just make sure that both sides agree on the same secrets. There isn't a man in the middle, or I should say an attacker in the middle. We're trying to use ungendered terms here. There isn't an attacker in the middle that's terminating the TLS session and starting a new one. So with channel binding, you get that. It's used by client authenticated TLS. So if you're using a smart card, or not very frequently a client certificate, soft client certificate, you get phishing resistance that way. At the time 863-3 came out, we were expecting that a new technology called token binding, which came out as an IETF standard, was going to be adopted widely, and so that was kind of how we described it. Well, right after we came out, token binding kind of flopped in terms of vendor adoption. The major vendors said, no, we're not going to do that. Not entirely sure why. I think it might have had to do with firewalls and things like that didn't work very well with this. So in addition to this, in addition to channel binding, we now have what we call verifier name binding. So if you're familiar with FIDO authenticators, basically it generates a different authentication secret for each site that you register it at. And it uses the domain name from the certificate that's presented in the TLS session that you verify in order to determine what that domain name is. And so essentially you're creating a different authenticator output for each domain that you authenticate at. And that also blocks the attacker in the middle that is perhaps proxying, has the lookalike site for your bank, and is tricking you into going to that site. Well, when you authenticate at that site, that authenticator output isn't going to be useful when they in turn try and authenticate at your bank. So that's the idea here. We don't, by the way, 863 is a requirements sort of document. So we describe technologies very generically. And phishing resistance was probably a case where we got a little too generic. but we don't generally talk about particular implementations like FIDO and so forth in the document, just in order to try and keep it general and to allow space for other things that people come up with between now and when the next version comes out. So as a result of all the importance of phishing, the large amount of phishing that has been going on, the federal government in the U.S. has come up with some new requirements from what's called the Office of Management and Budget, which is a part of the White House. And so it extends to all executive branch agencies, which is basically all of the agencies that everyone thinks of in the federal government. And they've basically said, or not basically said, they've said that within the U.S. government, you must use phishing-resistant authentication and for all uses, and that by amongst federal employees, contractors, and that sort of thing. Generally, the U.S. government internally uses a smart card that's called a PIV card in order to do authentication, and so that is already phishing resistant. So that's a good thing. This kind of reinforces that. Says use a PIV, or there's a new specification coming out for what's called the derived PIV, where you can create another authenticator off of it, and that has to be phishing resistant. And it also says that authentication to the general public, say the tax authority, when somebody logs in to do something related to their taxes, that doesn't have to be a phishing resistant authentication because the public isn't ready to have that requirement on them yet. But it says that all government agencies need to provide that as an option. So it's kind of the first step, is to give people the ability, if they know what phishing resistance is, or suggested by maybe their tax preparer or something like that, they have that option to be more secure. Activation factors. So previously we had described multi-factor authenticators just in terms of, it was, say, a multi-factor cryptographic authenticator that, and you could use it with either a biometric or a memorized secret, which was our kind of more generic term for passwords. We may end up using passwords yet. We'll see, because memorized secret is another one of those sort of very more precise terms that isn't even all that precise if people use password managers. In any case, so what we've done is we've broken off activation factors into a separate section and kind of dealt with them separately. And a lot of it has to do with the fact that there's a different threat profile for an activation factor than there is for something that's verified centrally, where you've got a potential of a bulk attack on the all of the verifiers or all of the accounts in the verifier. And but on the other hand, we have additional trust required on the part of the authenticator itself, that it's going to securely protect that activation secret. Whoops. I think I said that already. Okay. So a number of you have worked on, especially with pins. By the way, not a fan of the term pin because it's not always numeric, and because actually pins, if at my ATM, as far as I know, that my pin is centrally verified. So I really, describing something as a pin doesn't really help. It doesn't emphasize either aspect of it correctly. I'd like to describe it as an activation, still describe it as an activation secret to emphasize the fact that we're talking about a second factor that's verified at the user device. So a number of you have, and we've had some side conversations, talked about the different combinations of parameters that go into the decisions about how long should an activation secret be, how many tries do you get, how many do you have a block list, how big should the block list be, how effective are all of these things. I'm really looking forward to the talk that's coming up, Collins's talk about 4-digit versus 6-digit, because that's a question that we're asking internally ourselves. So thank you for that. In any case, there are a lot of parameters here. They all interact, and we're really challenged here because we want to provide sufficient security with a memorized activation factor, but we are kind of over constrained. We get comments that maybe some of the smart card vendors tell us that they can't really fit a block list. There isn't a way to put a block list into the smart card. How can we do that? The number of digits. We've been saying 6 digits, but we also get comments that say, well, a lot of people are going to use their phones to their phones as activation factors, the PIN, for lack of a better term, on the phone as an activation factor, the unlock code. And a lot of those are legacy 4-digit values. So are we going to accept those, or are we going to make people, do we have a way of detecting the number of digits there? So there are a lot of those things. It's kind of an over-constrained problem, and we're going to do the best that we can in order to make things sufficiently secure and work within all of these real-world sort of constraints. And then one other area that we're introducing a new section on is external authenticators, and these are cases where maybe it's a card that is NFC enabled that is used, you use next to your device, next to your device. Maybe it's something that's Bluetooth enabled, where you might have to push a button on the card, and there's a number of challenges there with eavesdropping, with attacker in the middle attacks, especially for Bluetooth, because they're somewhat longer range and the attacker can be a little bit further off. And skimming attacks, potentially, probably more for NFC, because you don't typically have a button that you push in order to enable the use. Somebody might come up behind you, and I've seen demonstrations of somebody comes up behind and does a relay attack against someone in real time. So those are challenges, and we're trying to come up with good requirements for all of those areas. And then so those are the main areas. You'll notice I didn't say anything about passkeys. Again, that's a particular implementation of what we would call a multi-factor software cryptographic authenticator. Another mouthful, right? But we're really looking hard at what industry is doing in that area, and sort of trying to be responsive to that. But it's also a kind of a moving target right now. That technology is very rapidly evolving. Some things that were presented early on have changed or have gone away. You used to have things like device public keys, which apparently now are not in favor so much anymore. So anyhow, we're trying to stay as closely aware of that as possible and come up with something that makes sense, both in terms of the technology and in terms of the requirements for security. And then finally, I've got a few links here. You can take a picture, or you can, I think we'll have the presentations online later. But these are just kind of the major U.S. government documents having to do with this. So that's it. Are there any questions? Yes.
In the particular area of phishing resistance, the new verifier name binding, are you considering attacks? So as a security practitioner, I know for a fact from experience that phishing attacks nowadays also rely on what we call remote PNC or RDP, where when you get the phishing mail, for example, you click and the website is not a website, but rather a remote desktop connection with the browser inside, and you actually go to the actual website, so to your bank website. Even though it's another URL, it's just a proxy website, right, using RDP or VNC. Given WebUSB or WebBluetooth, which are standards that now Chrome and Firefox are planning or have already introduced, have you considered the fact that IO devices or any USB device might be able, with a good phishing mail, might be able to be forwarded to the remote browser? So basically, they would be able to authenticate on behalf of the user.
Okay, I'm not especially familiar with the particular attack that you're describing, the remote desktop sort of thing. I am having a little trouble imagining how that would work with a physical authenticator like a FIDO token, because it would certainly be able to get keystrokes from the user. So if it was single factor authentication with a password, that would still be a possibility. But I'm not sure how the connection to the
forwarding the device via WebUSB to the remote website. It starts to be possible. So for example, you can use websites to communicate with your USB devices right now in Chrome and Firefox. It's not an actual attack right now because this is a draft and it's not being implemented anywhere, but I'm curious if you've designed the process in such a way to prevent that.
I guess I can't say that we have because I'm not familiar with the attack, but let's talk afterwards and get some more about that.
For lunch. And of course, it's fully possible to talk to Jim and to Deb. Jim is staying here for quite a few more days as well, so if you are that as well, chances are, they are really there to talk to Jim. But for now, lunch, I have brought in catering food. There should be more than enough for everyone. So just go out in the hallway and I will more or less be your waiter for the day. Thank you. Okay, then I hope everybody enjoyed lunch. somebody didn't finish all their food, so I will be making sure that you actually finish all the food in the next break. Not letting anything go to waste. So we have Thomas and we have Sebastian, and I will just leave the stage for them.
Yes, so welcome everyone. The protocol we are going to introduce is a joint work with 4 of the authors, 2 from UEO and 2 from United Arab Emirates and at the Research Institute. So without further ado, let's jump into privacy-preserving password cracking. So, contrary to common belief, passwords are really not going anywhere, and we will keep using them in many different areas. And for that purpose, we really need to upgrade our ability to test passwords. And this is especially important in key roles. And I like the example that Per gave in the beginning. Like if there are important service account and domain owners and they are choosing weak passwords, that's like the nightmare for every CISO. And there are legitimate ways when somebody wants to crack a password in an organization. So it might be a red teaming activity. The red team retrieves a hash of a password and they would like to crack it, but maybe they don't have the resources or they don't have several days. So they want to use a third-party password cracking service. And that's a very risky thing to take, for example, an NTLM hash and then transfer it to a server, because not only they learn the hash, which can be used for pass the hash attack, but if they crack it, they learn the clear text password. So our goal is to introduce a protocol that allows you to take a password hash that you want to crack, send it to a third party. They will not learn what the hash value is. They crack it. They will not learn if it's cracked or not. You will learn it if the cracking was successful. And if it's cracked, they also don't learn what is the clear text password behind your target hash. So it's quite ambitious, and we are not using any kind of homomorphic encryption for this. So that's the setting. So yeah, some key phrases. We're going to use some decoy hashes and an anonymity set-based approach. And we can also verify that the third-party server did the computations that we actually wanted through a proof-of-work mechanism. And I also have to say that this unfortunately has some malicious uses because it provides plausible deniability. So if there is a malicious CISO at the organization and he's like, yeah, I want to take these password hashes from my organization and put it in this anonymity set and send it somewhere, it's like you can't really prove it on them that they can claim it was another password in the set that they actually wanted to crack. So the structure of this talk is going to be, I will give the word soon to Sebastian to talk about traditional password cracking and some of the challenges that such a protocol would need to face if we are sending a really large number of hashes to a third party. We look at some similar schemes and basic principles of the 3PC protocol. And I will have a toy demo with John the Ripper where you can try to guess which is the password that I have selected and I actually want to crack. And then we will get into more of the details. So now it's Sebastian's turn.
Okay, so hello everyone, to whom I haven't said hello already, and thank you very much, Tomasz, for this opportunity. So I don't want to risk stealing of any of his thunder. It's entirely his presentation. I've just been given this nice opportunity to give a forward, especially since, as Per mentioned, I've been attending PasswordsCon for a while, and I think that's also a good example of what I really like about this conference is not only the content is, in my opinion, at least already very interesting, but I find connecting with people here is even more interesting, at least to me. So for example, that's how I got into Team Hashcat, who competes in international, like maybe even the world's #1 password cracking competition. For example, in DEF CON, it's called Crack Me If You Can. because most of the team, or at least the founding members, or the author of Hashcat, Jens Stoiber, was presenting in PasswordsCon before. And another interesting coincidence like that was that in 2014, if I'm not mistaken, so yet another reason why we really need to recover those old videos, but now a colleague of mine, Norbert Tihani, so one of the co-authors of this paper, I work with him, and Thomas was his student, so it's kind of a small world, but at the same time quite the impactful world. I mean, I feel really honored when consultants for NIST, not NIST themselves, but are saying that what we say here is taken into account. I think it's really amazing. So yeah, all that to say that, well, probably a lot of you, if not everyone, already know what is password cracking, how does it work roughly, but I would like to just make sure that we are all on the same page with some basics. So of course, if you know already what I'm going to say, please just make sure that we are all on the same page before Thomas gets into the really hardcore math that even the IEEE now has been having trouble finding reviewers. So the paper is a bit delayed because it's too complicated, or maybe there are not enough people in the world who understand the rest of the presentation. So let's start with the beginning. So obviously, what is cracking a password? Well, you start because, well, there are still people who talk about encrypting passwords, decrypting passwords, and really that's not how it works. You take the input and you use a one-way function called the hash, and the way that attackers will try to reverse this process is not really reverse it, it's just they are going to try all the possible combinations, or like word lists and so on, to see if they can get the same output, at which point they will say, okay, well, I have guessed the password. So that's why it's the inputs are then called guesses or candidates, and the actual cracking process is trying to do those guesses as quickly as possible and then comparing the outputs with the one that we are looking for. As Thomas was saying, as I keep being proven wrong, or how to say, like a bit embarrassed about my 2012 PasswordsCon conference title, when it was called Putting an End to the Arms Race, or something like that. I thought, well, sure, how many PasswordsCon can we do before we stop talking about passwords? But it's already like 20 editions or something. So yeah, definitely it's not going anywhere. And as was already mentioned earlier this morning, also like two-factor authentication and so on, it's not the silver bullet, or how do you say, like the solution to all of that. So definitely there is still value to look into cracking passwords or risk-based authentication and so on. So
I think you went backwards in the slides.
Oh.
Let me just
sorry,
get into
me and computers.
Yeah, view and then slideshow. And now we can actually jump. Yep. Yeah, because now there was a timeline.
How to
okay, and now this is your slide.
Okay, so which button do I need to press? Like I've never used it.
Down arrow.
Okay, sorry about that. So yeah, just a primer about even the hardware for password cracking is interesting to talk about for a minute. So like a CPU, the main brains of your computer, you can basically tell it to just, do this, do that, whatever you want. It's capable of doing everything you've seen ever a computer do. So what is the difference with GPUs, the graphical processing unit, which is what came from basically playing video games or 3D modelization and so on, 3D modeling. And if nowadays the latest generation, for example, has 16,384 cores, why would we still keep like the boring CPUs that have only 32 or 64 of in the most expensive ones that you have nowadays? Well, it's because it's many more of them, but it's far from being as flexible. So you have to, you can gain the performance of that high number as long as you make them do all exactly the same. That's called the SIMT, as in a single instruction, multiple threads. And it means that you have to change the way you're thinking of your programming, as in you cannot even do, if you want to not lose performance, you cannot even do like a if-else statement. Because if you have to do something if, it means that all the other cores will be waiting for their turn and so on. So programming GPUs is already its own thing, and FPGAs is a whole other world of its own. It's not, I wouldn't even call it programming really, although of course it has to be programmed in a way. It's more like emulating silicon. So it's really like a FPGA means field programmable grid array. So you can tell it basically, I would like a transistor here, I would like some like traces there, and so on. So it's awesome for when you can well, emulate chips, but it also means that the bigger the chip, the less interesting it is. That's why FPGAs, for example, are great for cracking DES or bcrypt, which would be small chips if you want to make chips for them. There are actually some chips. But for more complicated algorithms like SHA-1, SHA-256, and so on, then it's much less interesting already than a GPU. So each one of them has pros and cons, and as Tomasz will explain, now we even get into the details of the particular instruction set. So even maybe today one is the best choice for a particular approach, but tomorrow it might be different if a new instruction set is introduced, as was the case towards the beginning of PasswordsCon. There was a new instruction that suddenly helped Hashcat a lot, which was the bit rotation, if I'm not mistaken. So about the slide, finally. So GPUs are awesome, but of course it's you still have to abide by the laws of physics or the laws of computation in a way that even the smartest list sorting algorithm or like list search algorithm, even if it's taking less impact on the performance than another one, the more data you have, the slower it will be. So of course you want to keep that data to a minimum. So that's what Tomasz will explain, even though in the original brainstorming there were some solutions kind of like that security through obesity thing, where we were thinking, well, let's just make the data huge. But then, of course, if you have to search through that huge data to make sure that you have cracked or not cracked a password, then obviously it's going to be slower regardless of how amazing your searching algorithm is. And then, of course, there are different considerations in terms of within the GPU itself. Already there are several tiers of memory, as in you might have even like registers in terms of CPU. For example, you can imagine that registers are as fast as possible. Then you would have level 1, 2, 3, maybe even 4 in the new CPUs cache. So it's kind of the same idea with GPUs, that you have like local memory, shared memory, global memory, and then only then the computer RAM. All of that is making already exponential difference in terms of the performance that you will get. And that's talking about memory only. So of course, then if you have to consider about reading or writing to actual storage, as in SSD or NVMe, or NVMe, SSD, and hard disk drive, then it's orders of magnitude slower. So all of that has gone into consideration for the talk. I hope that we are all on the same page for this. Just to give you a quick example, so these numbers, it would be nice to see like a cliff on a particular number, but it has to be generic anyway, because that depends on a particular GPU architecture. So each generation, like the NVIDIA 10 series, for example, was Pascal and so on. So they each have their own specifics of exactly how you would optimize your code to work on that. And that's why in Hashcat, for example, you have maps that are trying to adapt each kernel and so on, like each code to the particular GPU that you have in your system. But roughly speaking, you can see, for example, between the first and the second rows, that as soon as you have several candidates to look at, it's much slower already, because it might have been much faster to compare against one particular target, because maybe that fits into something like registers as closely as possible. It's like giving the processing unit what it's checking, you let it keep into its hand all the time, so it can keep checking as quickly as possible. Or as soon as you have several, then you have to like go fetch from memory, compare. Even if it's fast memory, it's already almost like half slower, and so on. And of course, the more entries you have to keep comparing with, the slower it becomes, until you get into the next tier of memory or even storage, up to a point where it's even impossible to keep it stored anyway. So I guess your turn now.
Yeah. Thank you very much, Sebastian, for the intro to the existing issues. So just to summarize, our goal will be to have the third-party server crack an enormous number of hashes. And we already see like small sets like 10 million. There was a significant drop down in performance. So we are now going to look into some of the related work or concepts that can be considered, like how am I going to hide my target hash? So one idea would be to maybe try to hash down a couple of dictionaries like the RockU dictionary, and then stick our target hash into that set. But that really doesn't provide a good anonymity set. So not only that would be easy to reverse all the other hashes, the attacker can quickly figure out what was the creation mechanism, but I have no idea, that's why I want to crack it, like I have no idea what that target hash is hiding. So maybe it's a Chinese password or a Spanish word, and how am I going to guarantee that I hash all kinds of different decoy passwords that will guarantee an anonymity set for the hash digest, right? And I could go, if I want to really increase security, then I'm going to hash down a lot of things, and you just end up with an enormous data set that will be very difficult to transfer. And so this really doesn't allow scaling. And there was another idea which is now close but still not perfect. So if you know the Have I Been Pwned website, you can check if your password has been compromised. And the more secure way to submit your password is not to submit the hash itself, but you delete a couple of characters. And if there's a password there that has the same couple of hash characters, the first few ones, then maybe you can have a guess that your password is compromised with a certain probability. Of course, this is not good for password cracking. So I take my target hash, I delete the last character, for example. Then if it's a hexadecimal representation, then I have a set of 16 hashes. So one will be a real password that I created, and the other is most likely just completely random strings that I will never find a pre-image. So how am I going to guarantee that if I give like a range of hashes and I define a data set which I want the third-party server to run through, how am I going to guarantee that there will be enough passwords reversed in this set that will guarantee an anonymity set for my pre-image if it's found for my real password? So yes. So for the purposes of this demonstration, the hash function that I'm going to use is CRC32, which is not a cryptographic hash function. It's not secure and it's not used anywhere, but it's short and it's really easy to represent. I don't have to fill the screen only with really long hash outputs. So I'm just going to very quickly tell you like a basic principle of what we are aiming to do. So this is going to be the target hash that hides my actual password that I want to crack. So what I'm going to do is define a range. So for every character of the target hash, I will define a degree of freedom. So first one, it can go from C to F, then 2 to 6, and so on and so forth. So what I'm giving to the third-party server is basically this lower bound and the upper bound, and in this vector V. And what I'm going to say to the server is that, for example, here's the RockU database. I would like you to perform the cracking process with that. And what I want is give me all the password hashes that have a format that can fit in between these two sandwiches, right? And in this set, there are like 5,880 hash digests. Okay, and now a little bit of why this approach works, a little bit on how hash functions work. So if you take a single password from the input space and you hash it, because it's going to be a random distribution, so it doesn't matter if the passwords are really close to each other, it's going to pop up somewhere in the output space. So if I want to make, if it's a single password, like there's just one dot, and I tell you like, okay, you have one pick, try to pick the right hash output that corresponds to that preimage. Like what are your chances that it's completely impossible? It's 1 over sigma absolute value raised to the power of L. But if I give you k choices to pick, then each little choice carries this little tiny probability. And it will add up. So if I allow you to make this many picks, then your probability that the set that you select that contains the output is 1 because you selected the entire set. But what we are going to do is just select a subset of the output space, this XV. And the very concrete example that I'm going to give is the data set is actually going to be now RockU with 14 million passwords. So the real question is now, if I hash down all the passwords from RockU, how many will fall into this little set? And that it absolutely has no relevance what is inside my cracking data set. It's just the size of it. And it's this really simple formula. So what I expect is that the number of hashes will be around like 20 that is correct. And to demonstrate this, we are going to, yep. So this was the lower bound vector, which we are going to then generate. Okay. And then take the upper bound vector. Right. So now we have this output.txt, and it's in the format that John the Ripper can treat. But really what is important is all these different hash values. So we have this range of hashes. Okay. And then, not this one, this one. Okay. So then we launch the RockU database. And one quick reminder is that John the Ripper, it doesn't support the 3PC protocol. So in this toy demo, although we have all the vectors in this output.txt file, in the protocol we will only have the lower bound and the upper bound given to the third-party server. All right. So if you have paid very close attention and you memorized the target hash value, then maybe you can immediately tell me what is the password, but I'm pretty sure that nobody has done that. So I will just, sorry? Okay, thank you. Yeah, that was it. But otherwise, for an unsophisticated eye, it would be not super obvious what is the right password. And in this case, you had an extra knowledge, like you knew that the target hash is in this set. Because what this protocol guarantees is that if I switch RockU to something else, it will again give me a candidate set from the very same dictionary. So maybe I emphasize that this protocol, what it really allows you is very accurately control the number of candidates you get back from whatever data set you use. So it gives you a random subset of the original data set with really high accuracy, like you can select exactly how many you want. But let's remove this. And now say that I'm going for a different dictionary with French words, and it has just, it's a little bit less than RockU, but we can pump those numbers up by appending a digit and a special character to the end. Right, and then launch the attack. Okay, and this is now, oh, of course, and the expected number of candidates for 265. So I can already tell you that this is 277, so it's in the range. And if I would ask you now, like, please tell me which password, is the one that I was originally trying to recover. The reason you couldn't do that is because it's not in the set, right? So 0bcrest is not in this set. So that's something that the attacker will never know. So the target hash is only cracked if the cracking dictionary used produces that value, right? And whenever the attacker sees this result, it will never know if the target has actually cracked. So going back here, and as mentioned, this vector v, it really selects a randomized subset of the original data set. So if I select another lower bound and upper bound, but the very same number, so also 588, just like the very first example, then I'm going to get, but I select it in a way that it always contains the target hash. Then I again have really a completely different set of passwords here. And about ranking, like if you pick a database that, the probability of each password, you can do all different analysis according to Markov model or statistical, like this is a frequency table, for example. But you could do a complexity check. So based on if you are an attacker, you will say like, okay, I want a password that kind of satisfies certain password policies. So then maybe you would go for Kiss Army and my password here. But you are making assumptions at that point about the potential password. And yeah, so a little bit more details about what the protocol will do. So instead of giving the third-party server all those hashes and they need to write that to disk, we're just going to give this lower bound and upper bound. And then there is a more sophisticated way, like it needs to satisfy this predicate function, which is basically we'll check for every character that is inside this set. So if that is fulfilled, then we say the predicate function is satisfied, and then you can write that password to the disk. And no need to send all those vectors. But now I cheated a little bit, because I started with, in the toy example, 5,880 passwords or hashes, and that was a special number, for the reason that when you actually want to ask, like, okay, how many candidate passwords I want in my anonymity set, you're actually picking this number, which was 20. And based on that, you can calculate kind of how many numbers you need in the decoy set, so how many different hashes. And that is not super easy to pick, because that number, it needs to be in this special format. So you remember that we had this slot with the degrees of freedom. Well, of course, we are in hexadecimal characters, so each character can only have 16 degrees of freedom, right? So if you say that you want, I don't know, 10,017,000 as the number of decoy sets, then you have to do prime factorization, and if it has a big prime factor like even 17, which is larger than 13, you cannot distribute that. And this way, what you need to find is the number that is closest to your desired number of vectors, which is in this special format. And not only that, for example, if you think about this small example with the CRC32, if you have like 5 to the power of 9 already, you cannot fit that into the set, because you have 8 slots, you put 5 in each, and then you have 5 degrees of freedom remaining. So if you multiply it, then it's immediately 25 possibilities for one slot. And you cannot actually do that. And how to solve this? It's like a 7-variable integer relation problem, which is quite sophisticated, and I'm not going to get into the details of that. But it's actually not that easy. But from the perspective of our protocol, just to summarize like how the whole picture looks like, is that the client first asks the server, like, okay, what kind of hashes can you crack? What is your hash rate? The server responds, and then you select the cracking data set that you want to use, and define also how many candidate passwords you want to see back, very importantly. And based on those numbers, you will determine how many decoy hashes you need to give to the server. Not all of them, but of course the range. And there is this, for now, black box function that does this problem solving for you and outputs a number that is in the right format and is really close to your desired number. You send those parameters back, and the rest is easy. It just does the cracking process, and it will transfer you back all the passwords from the data set where the hash satisfies the predicate function, right? So those password hash pairs. That is what you get back. What are the attacks that are possible in this scenario? So when you define that range of hashes, like in the sandwich, can the attacker make a guess based on that? Well, obviously there is no correlation. You're just looking at hash values. You have no idea which one of them hides legitimate passwords or which one is random. So that's really not going to work. Maybe look at the cracking data set. So immediately look at, okay, he is asking me to hash ROCU. Maybe it's in ROCU. But only a random subset of the ROCU database will satisfy the predicate function. So the best strategy for the server, if they really want to make a good guess, is to do all the computations and actually find out the candidate set. So can they then maybe guess from the candidate set? Well, what guarantees that the password, you yourself don't know if the password was in the original data set. Otherwise, if you know, you're not going to use this service. So, but in order to provide a good anonymity set, it's up to your desire how much candidates you want back. And what this will guarantee is based on the formula you can accurately know like how many the server needs to give back to you. And then you can have a statistical argument. So if they only give half as many, then you can say that they were dishonest and they didn't expend the right amount of computational effort. Okay, so what about other attacks? Because in theory, many protocols are secure. The RSA protocol is of course very secure, but there are so many attacks if you incorrectly pick the generator, the prime numbers. What if there is like a practical attack against this protocol as well? And there are some possibilities that if you configure it incorrectly, what the attacker can do. So if you define a cracking data set, which only holds a small amount of personal information, so it's, for example, Per Torsheim and birthday and pet names and positive past life events, and you give that to the third-party server, are they going to be like, maybe this password belongs to Per and he's trying to test it, or one of his employees or something like that. And reality, okay, the server might see this information, but you can say that you want a candidate set of 10 million passwords, and there will be 10 million passwords per Torsheim 1, per Torsheim 2, 3, exclamation mark, so on and so forth. So it is really up to you, and then you can maybe define a little bit more generic data set if that is your concern. Attack scenario number 4. Okay, you defined a scenario. You had a bcrypt password, so you couldn't perform the computations on your laptop, and you wanted rock you with some mangling rules, right? So you sent it to the third-party server, and they are going to be like, aha, so this is the range of hashes that has the password. I'm going to continue with further attacks. Okay, but for every data set they try, every cracking data set, they will get a number of candidate passwords. And at no point will they know, like, okay, which is the right data set to use. So they are just going to grow and grow and grow the candidate set, which will be, and at a certain point, if you configured your parameters correctly, they can't run, for example, a brute force attack, because so many vectors or so many passwords from the brute force attack will satisfy the predicate function that they will run out of space completely. So they can't really scale the attacks. And even what they do, they will get candidate passwords. So before I jump into the last attack scenario, I will tell you about the real world experiment which was done on this Rivera FPGA. And right, so the scenario is that the target hash we want to crack, we know that it belongs to a service account, and for the example it's just uppercase, lowercase, and digit, all combinations. So the entire data set is a brute force for 60 to the power of 9 elements. Okay, and we want kind of 806 million candidate passwords. That's how we defined it. And as an NTLM hash, Sorry? Yeah. So with an NTLM hash is obviously 16 to the power of 32 all possibilities. So then it's 16 to the 26 number of decoy sets that our set needs to contain. Okay, that's quite large. So it's like 17,000 times more than all the data capacity in the Word, which is a couple of dozen zettabytes. Okay, so now it becomes obvious that you cannot really write down the decoy set into a file and hope that it fits into the memory of the GPU. Okay, so the experiment was we first ran Riviera against a single NTLM hash, the brute force attack, to see how well it performs. And then it obviously cracked it because we knew that it's in the set. And it took 19.6 hours. So then we ran the attack against the this vector that hides our target hash. And it was the same amount of time, which is very cool. Okay, it was actually 50 seconds slower. And the result was that we got 806 million passwords in the candidate set, which is like 20 gigabytes. Of course, again, there is a sort of zero knowledge setting to this protocol. So if you want something so small as the RockU database and your only concern is that you cannot perform the computation on your system, what you can do is ask the third-party server to hash it for you, but then your vector or sandwich is just 000FFF. So it's kind of a zero knowledge setting. But in that sense, every single password hashed will satisfy this range, right? So you get back the entire RockU database hashed, which you can do if you can transfer. It really depends on your bandwidth. But as you are getting into larger and larger data sets, like in this example, that would not really be feasible. So you're very happy with 806 million passwords, which is going to be like 20 gigabytes. It's still kind of transferable, but you get the idea. And here is the just output of the cracking process. So back to the ranking attack. So if we were, for example, wrong, and that NTLM hash was not a random generated string, but in fact a human chosen password, then that anonymity set, we could argue, it's not sufficient. It doesn't provide perfect K anonymity, because we ran the crack-lip check function on this 806 million candidate passwords, and most of them were random, and some were based on like dictionary words, or they look like national identity numbers. And you can find some really, really human-looking passwords. Of course, it's a random set, so we found like VNB Batman, PayPal, SQC, Mr. London, 26, so all kinds of human-looking passwords, but it's of course a small percentage. But in this scenario, what we wanted, so reminder, that vector you define is selecting a random subset of your cracking data set. So of course we did a brute force attack, so it's a lot of random characters, so random subset of that is again going to be a lot of random plain text. So you have to be sort of careful that you are not defining, because the larger the data set is, right, the smaller you're going to have to shrink your decoy set in order to avoid getting too much results back. But in this setting, if you really think about it, because the problem is that if there is a password that, for example, password 1, that uses all 9 characters this very human-looking, efficient way, it's kind of probable that maybe that is the password. But again,
Kirsi Helpala, as mentioned, she's been with us since the very beginning of PasswordsCon, so I'm really happy to have her back. I didn't even have to call her and threaten her to come here. If I did that to someone, it was no harm intended, of course. It's just a way to convince people to come here and talk sometimes. This, again, one of the many talks, well, all talks I'm looking forward to. And I'm also looking forward to this one, so let's see.
Thank you. So I'm Kirsi Helkala. I work for the Defense University College. So basically I work for the Norwegian Defense Forces. And if you, I just have to say one thing about the passwords, which are the good passwords. If you use words, please misspell them. Do you see my misspelling? It's as missing in PasswordsCon. So good password if you use misspellings. Okay, my work. I present today two papers, or the result of two papers. I have worked with Stephen Furnell. Many of you know Steve. And Naomi Woods. Naomi works in Finland and University of Jyväskylä. And we had, I call this a COVID project, home office project. And we had fun, I put it that way. We did study disabled people or how they cope with authentication mechanisms and methods, and ICT and overall. A little bit of background on what I was supposed to say today. We had a hypothesis that even if technology has evolved a lot during the decades, that authentication methods have really not. And we wanted to see if the cases or the issues that disabled person and people have had before, are they still valid? And we used classification made by the World Health Organization. I will go through it shortly. And also the universal design principle in our work. I will show some examples, mainly from the UK, from Steve. And then short results from a tiny little survey we did in Finland and Norway. And then a huge table, not going to go through it all, where we actually evaluated authentication methods. And I conclude with some recommendations. So yes, I know this is very small text. So this is the international classification of functioning, disability and health made by World Health Organization. And it contains 12, or it's actually very huge, but we put it in we just took the over titles. So 12 categories: intelligence, attention, memory, vision, hearing, competence, life support, spoken messages, non-verbal messages, lifting and carrying objects, fine hand use and walking. And I'm quite sure that you all know what the memory, vision, hearing and walking means, so I'm not going to go through those. But intelligence, what we mean and WHO means is that the person's ability to have a higher level cognitive functions and ability to use or to carry on several tasks at the same time. Attention, that's a person's capability to hold attention and sleep, energy and drive functions, orientation, and then competence. That of course is very much related to the intelligence, but in this case it means a person's capability to attend to school, kind of. Are they able to have guidance to learn to read and calculate? And while I was listening to the earlier talks today, I was also thinking that the competence, it has something to do how competent you are in using ICT. So you can be very intelligent in other ways, but if you are not studied, if you have not studied ICT, you might have a lower competence there. Life support, that's the thing we quite often do not think about, that it has something to do with the authentication. Life support, there we put heart, blood pressure, skin issues, respiration. Spoken messages, that's something we all here can do, but not everybody. So spoken messages, that's a person's ability to communicate with spoken languages. And non-verbal messages, people ability to communicate with non-verbal messages, that you know a language, sign language, for example. Lifting and carrying objects, that means that you can do this and you can carry. Fine hand use means motoric, the fine motoric. So of course these two are kind of related, but you don't need to fine motoric to carry objects. Even if you have a non-functional fingers, you can still carry objects. So these are our 12 categories, what we have looked at. And then here are the 7 principles of universal design. Have you heard of this? You should. The legislation has been done several years ago, but I think it's just kind of that now everybody has to really use it when they design new products. So there's, as I said, 7: equivocal use, flexibility in use, simple and intuitive use, perceptible info, tolerance for error, low physical effort, and size, space for approach and use. So no matter what you are designing, is it a physical thing or a ICT related thing, you should look up these principles. Okay, so that was kind of the background what we have used, and then what we had done. Both of those papers I showed, mostly they are basing on the literature study. So we have checked the relevant papers, reports in Finland, Norway, UK, Euro, kind of mostly holding European studies. In addition, we have done our own observation. And then we wanted to see if that what we have read actually had a real life backing. So we used a small survey. The survey was carried out in Finland and Norway. We had 10 participants, and the people we asked or who took participated study were either disabled or working with this disabled or both. And they are between 30 to 50 years. And why that? We wanted them to be a person who had lived before the digitalization hit, and then had to learn to use these systems what we are using now. So kind of have a feeling how they coped that and what they feel now. We had 3 with visible disability, 2 with hearing, 2 with motor disability, and 2 with cognitive. And if we list it with those ICF functions, we had attention, vision, hearing, spoken messages, lifting and carrying objects, find, hand use, and walking. Okay. Then next 2 slides, a couple of examples. And these goes now against those 7 design principles. This is an example from the UK password guidelines. The first one, you can see that there's a text telling you what you could do and should do or should not do as in a sentence wise, written in a sentence form. Next, then they give a list of symbols, what you can use. So those symbols are allowed to use. And then they have a bullet point list, should and should not do. So there's 3 types of different ways of giving information. It's confusing. So it goes against the perceptible info and simplicity. And then comes the fun part. Like everything else, if you give an example, you should at least give an example that can be used. So here in the example, we have a dash, I think it's called. It's not on the valid list of the characters. And then a person makes a password and tries to submit it, and comes a red box telling that, okay, it was not valid password, but it does not tell what you actually did wrong. So useless. So this goes against usability. It's very annoying for us, non-disabled. But if you have an intellectual problems or is disabled, or attention, or competence for that matter, it's rather difficult. Then comes an example what we found rude. People should have the same value. Are they disabled or non-disabled? This is a payment example. You try to make a payment, and the confirmation for the payment, the bank is going to give you a call back, and then you're supposed to say those numbers, those digits. And a normal hearing person could hear that now you have to give your digits. So they have thought that, okay, if you are here a little bit badly, they tell you, you need to enter the code 20 seconds after you pick up. So you pick up your phone, you count to 20, and then you give your digits. But it does not take 20 seconds to say, please enter your code. So there obviously is a message that the normal hearing person will get. But then the bank has thought that, okay, it's not important for the person who does not hear. Rude.
You mean at least 20 seconds?
Yeah, exactly. Good point. So in the papers we have a couple of more. May I show you too? Then we had the survey, as I mentioned. The survey we basically asked what type of password methods they use at work, at home, on PC, or on a phone, or if they have another equipment, what they are and what they use. And what do they feel about them? It was more this open which means that they are easily to guess. Usability issue come from there that you of course have to use the same what you enroll when you try to authenticate, and it has an impairment in intelligence. There comes an issue. Tokens, user dependent or user independent. There's no problems in the usability because somebody can always guide you that you have to, you put it there and then you get in. Security issue there that other one can easily take it from you. Can I share it? Sure, of course. Then biometrics. There we did not find issues. None of here, but in typing and signature. Security issues. Usability issues, again, somebody can help you that you're supposed to type your name or you're supposed to sign your name. But if typing, that you're supposed to type a longer thing, you are not going to do it, you maybe keep it shorter, and maybe you do it like this. Then I can do it exactly the same pattern. So there comes an usability, security issues. Signature with the same thing. You see them, write them a little bit. Okay, our signatures are messy. That's not necessarily other way around.
If I may ask, what is the problem with the PIN? You say that for passwords it's difficult to remember to use all the different categories, but PIN is usually, if we put it like only numeric PIN, 4 digits. Why would that be an issue?
A PIN, you mean?
Yes.
And the usability security?
Yes.
Which one, or both?
Usability.
Usability, that you're supposed to have the same that you enroll the same that you use later on.
So remembering even may be a challenge.
Yeah.
Okay.
Remembering comes kind of in the remembering, but yes, in this case, yes. It's not just if you have 4 digits, of course it's easier for you, but you can have a 6 or 8 or, so it depends. So we have taken the whole range, not just those 4 what we use for PIN. So maybe that was your issue as well. We should call them something else, the code or the strings. Yes. So then we kind of counted how many challenges there are, and then we run out of columns, so I have not listed here the total sums, but you are capable of seeing it. Here are those ones who had less issues. So user independent tokens, they have 3. Ear has 2, iris has 3, retina has 3, face 3, fingerprint 3, K 2, hand 2, and vein recognition has a 2. So in our evaluation, those would be those to be used. Of course, like I said, we have not taken into account the total security what they can provide. And if we start to think about the total security of the things or how usable they are, then we come to these practicalities. Hand geometry and vein recognition. If you take a vein from the hand to hand, need that. You need a large sensor than your phone, so it's not handy. Same goes a gate. It's not so reliable in every situation. Retina and iris, have you tried them? I find them uncomfortable. So that kind of leaves us the user-independent token and face and fingerprints. And those are kind of what we are using already. Next slide, if my computer wants to cooperate. My final remarks. So, what we wanted to point out, or again highlight with our papers, was that whenever ICT systems are designed, implemented, authentication methods included, one should think about those who have disabled. And actually, we don't understand why can we do it other way around. Why wouldn't we design and services and methods that could be used for the disabled people? Because then we can also use them with no problems. So the user groups, test groups, should contain disabled persons from all the functionality groups. And there exist lots of, or at least several frameworks meant for authentication. If you design new authentication methods, so you can run through the framework and see where you can improve it or kind of test it out. For example, Corax and Simics fishbone model. That has then 7 attributes: security, usability, accessibility, pricing, complexity, privacy, and convenience. And then it's very, very low and very, very high. You label them, and then you can give a score for the method. So you can rank them. So we have been thinking that our way of doing, our way of evaluating authentication methods could be combined the fishbone model. And then we also continue to talk a little bit longer. Now we have only considered usability and security. But we could also check what those, if you have an impairment in those functions, what does it do for the pricing of the technology if you have to cope with them, have an extra equipment, or what does it do to privacy? So kind of add those in not just usability and security, but other attributes as well. And then I think I'm beating my limits. So thank you.
Questions?
Yes,
yeah.
Jim.
Could you go back to the password change page?
This one?
Earlier than that. Earlier, that one.
Yeah.
There are just so many things here. This is and you caught a lot, but I mean, there's even
short question, Jim.
How much? Well, they kind of suggest you change Sunshine 1 to Sunshine 2, which is pretty funny. But how much of a usability problem do you consider their description of the special characters versus the fact that they even have particular special characters that you're allowed to use?
What can I say to that?
I mean, they should accept all the characters. But Google doesn't. Yeah, so Google should too.
I said, do not argue with that.
Yes?
Can you go to the table? Can we make passwords more accessible by 6 maybe down to 2 or something, using biometric like iris recognition and the password manager as a tool to enter the password, but the authentication at the very end, the local authentication is your iris and not the password anymore?
Yes, so here we have only thought is it a single authentication method. So of course, when you start summing it up, then you can reduce the character sets for the passwords. So of course, this is for the, thank you for mentioning, I should have said that we just evaluate it when it's used for single authentication.
More questions?
Yes?
Yeah, I find it very interesting insights here. How did you actually recruit that special type of participants? Because I can imagine from the research perspective that it's not easy to first to recruit these participants and how to communicate with them.
Yes, I have done a similar study before. So I knew a couple of persons to go to, and then like that. So I know one, and he knows one, and she knows one, and then what is called snowball.
Do you want a passing score on your exam?
Works always.
Always works. Okay, any more questions? Then we will do a 15-20-minute break before the last talk, the official talk for the day, and then after that, here's pizza, competition, and lightning talks. Thank you again. so we have everything online. So this is Espen. He's the CSO of Visma, and Espen is a friend. And I'm not going to say anything more, but I think this will be an interesting talk. That's all I have to say.
Thank you, Per. So to separate myself a bit from the other speakers who have been here today, I will not come here to present some research that I've done myself, but I will give you some experience sharing and call it from a convert. And I've also boldened out some words and to indicate that passwords screwed up music for me for a while. So for those of you who know the narrative, it should be quite fairly simple. But I'm here also as part of my penance. I'm basically I'm humbled by a bet from Per. So a bit who am I? Because I know some of you, but most of you have never met me. So who am I? I'm the daddy of 3 girls. I'm 53 years old, so I'm 1 year older than that guy. I am really into midlife crisis. That's one of the most fun parts of life for me. And so far, I think I've had 5 of them. And the current one is sailing. And my wife is also into that, so her midlife crisis is horses. So we are really broke these days. We have 2 very expensive hobbies.
As if the 3 girls didn't do that for you already.
Oh yes, and there's a horse and a cat in addition. As a job, I am the Chief Security Officer of a company called Visma. I'll tell you something about that company also. But this is also a bit about myself and my own preferences in life. I've always been really passionate about security. I've been doing this for quite a while. And this is, if I'm to be honest, what I've been doing more or less since 1989 approximately. So I've been doing security in some sense, either wearing a uniform or without a uniform. So for most of my life, my professional life, I've been a civilian, as I've been for the last 20 plus years. And for parts of my life, I was an officer in the armed forces. For about 7 years, I worked as a private contractor trying to infiltrate criminal environments. So I basically worked on the cover on the internet for a very long time and trying to figure out what made them tick. Figuring out how they broke the systems of my clients. I worked as a private contractor in that. Today, I sit as part of the management of a quite large company. And as that company, I try to run security over multiple countries, in many languages, in many continents. And my specialty is application security. From other parts of my background, my father, I was so inspired by Kirsi's talk that I have to share this also. I was not planning to do this, so it's a bit improvised. But I also have a father who has Alzheimer. I do have my mentor from childhood who also has the same disease. So I've seen up close what these conditions can do with people's ability to do digital things. So from being a programmer, a man who made circuit boards, to a man who is unable to get out of the room even though the PIN code is written on the door. That change is dramatic. So I strongly support any work in accessibility, and universal design is, of course, on my list. From my professional career, I have been really into sophisticated attacks. I've always seen passwords as too simple. It is meant to be kind of sexy. When you see an attack, I can be quite excited if I see an attacker who has done something really sophisticated. I'm a sucker for side channels. I love to see side channel attacks. I've even studied Tempest, for those who know what that word means. So I've studied lots of different methods that I'm really, really into. So I've always seen kind of passwords as, well, it's just too simple. It's not supposed to be that simple. I did make a bet with this gentleman. I'll tell you more about that. I've also been part of some research. So if you search for my name, you'll find a couple of articles and a couple of book chapters to my name, but mostly on application security, which is my specialty field in security. The company I work for is kind of large in Norwegian context. So we basically have some employees. But the most distinguishing thing for most of us is that we make lots of product. We make lots of software. So in excess of 700 products that people use all over Europe is part of what we make. We also buy a lot of companies. So we have bought 42 companies last year. This means that I take in quite a lot of the world as part of our daily job. So while doing that, I learn a lot about the cultures and the way they do security in different parts of the world and in different parts of both in South America and in Europe. So that's where we are focused. This is how I perceive threat normally. So I see threat actors on the left, and these are the assets that I am set to protect. So the threat actors, we spend lots of time and effort in figuring out the intent of them and the opportunity they have based on the weaknesses that we do have. And we also study each of these. We follow them extensively. And this is part of it. So far, passwords has not been a very hard focus for me until I started listening to this guy. So we made a wager. We made a small bet. So every time a password was the predominant part of a breach, that was the reason for the breach, I had to play some music that he liked a lot and that I disliked a lot. So that would be, of course, Bee Gees, which is, I think, his favorite. So I would play that whenever we could find a breach that was being caused by password. And of course, if it was some exotic reason behind, something really fancy, something sexy, he would have to play another song, which is, I think it was Shaggy.
Shaggy, it wasn't me.
It wasn't me. And fair to say, I played my fair share of Bee Gees over the last couple of years. I have. So when you see or hear Bee Gees in the background, that is just to indicate that it has occupied quite a big part of my life in the last year. But I also try to share with you some of those things that this has led me to. So it's not only a negative thing to make a bet with this guy, it can also be somehow positive. So this is a song that my kids and my wife have learned to both love and hate. I'll have to click fast past it now, sorry. So in my normal day at work, I study these things, and so does my colleagues. We study the blogs of lots of the security researchers, and maybe some of your blog posts, dear ladies and gentlemen in the room. We study them with intent, and we try to find those sexy bugs that we can fix, and we can put them back into the development teams, and they can fix them. But we also study other things that's really sexy. We try to study try to understand the geopolitical realities of life. We try to understand what happens. What does this in the middle mean? So are any one of you familiar with the pictures in the middle? This is things that really makes me tick. This is the Vulcan leak. It's quite recently published. Here you can see design details from applications used for malicious purposes around the world. To see some of those who program missiles, to see that there are data sets out there of soldiers on the field, and we try to use this. We need to understand lots of languages, dialects, and have deep competency on many, many fields. So, as I mentioned before, this is what predominantly occupies our daily lives. We have to search for vulnerabilities. We have to make sure that we do our best to make sure that products that we deliver are secure. That's why I spend millions yearly on behalf of our investors to make sure our products are safe. But for some reason, this guy keeps popping up to me. So I'm spending millions on eradicating bugs in software. I'm removing them one by one every day. And I'm spending millions on penetration testing and bug bounties. But still, the password persists as a part of my life. So I think for a period of time, Per, about once a week, you forced me to play this stuff. I do remember one evening, I was in Iași on the border, almost up towards, it was in Romania, almost up there against Ukraine and Moldova on the side, very close to that area. And yeah, for sure I had to play that. I think I even sent you the video of that one. Yep. From a meeting room up in Iași, traveling. So I'm fully aware that passwords are being used in breaches absolutely every day as I see it. So after a while, I'm sorry, I hate that song. I just have to play it one more time. So when we continue our work, we study the threat actors. So here you can see APT35, Lazarus 4229, all of these lovely ones. And we know them, don't we? I think most of the people in this room have heard of them at least. And on the right-hand side, you have the criminals. But what methods are these people using? They are, sadly enough, also using passwords, many of them. Very few of them are sophisticated enough to only do a technically very well architected attacks. They seem to look for the passwords. But sometimes something new pops up, like Earth August Sky. My eyes almost went wet when they arrived on the scene again. Such a lovely name, very interested in Taiwanese software. And they arrived on the scene the same time as Nancy Pelosi went to Taiwan, approximately the same time. They're very interested in Taiwanese software, these guys. Sandworm team, who was very active just before some pipelines blew up in the Baltic Seas. So that was, for me, very interesting. And the rig that we have built around this is massive. And only one of them has really caught my attention in the last part of time. This is the password managers. And this is what I'm going to share some details about today. So what we are working on is, and this is what I hope to get some help from learning about Kirsi and some of the others who have shared some really good knowledge here today, is about how can we implement this in practice and how can we get people to change their behavior. So what we have done in the past and what we still continue to do, it is that we have a gamification method to help people select the right behavioral patterns. And this is then a metric, an index, that shows the performance in security for one development team. And as you can see, they are measured on several artifacts. That is what I was very keen when I saw your form of all the different parts of authentication. When you look at universal design, how can we measure this? Is it possible to measure? Can we put these measurements up against the teams to make sure that we can offer good, strong authentication solutions also in the future? So we have the methods in the background. We do need some researchers that can help us. I also reached out to a couple of you in the room. So if you would like to research more, we do have data, and we are very friendly to research. So this is my reality. And when we continue this work, there's over 100 people working on security every day, and still this picture comes up again. So what do we do with these passwords? And still I have to play that damn song again. So now, this was a momentous moment in my life. I've been talking from stages about this several times before. So about this time, this was 2018. And I was asked by the chairman of the board to take media front in a case where our intelligence supplier had pointed to that China had made an attempt at hacking Visma and stolen some of our secrets. And the only control I got from the chairman of the board was to do not lie, be honest. That was the only control I got. So, and I love that, of course. This is a mega challenge. But after all of that work, we used lots of sexy intelligence efforts. We used lots of reverse engineering, lots of effort into figuring this out. But what was the actual thing that was used for this hack? And now it's a very simple questionnaire, and you would, I'm sure, amongst anyone in the world, what do you think was the reason? What do you think was the thing they used for breaching here? It might be a password, yes. But not only that, I'm sure that this room will be able to tell me what the password was. And now, Mr. Fenton, I will play you up against Mr. Torsheim. So at this moment in time, I think the recommendations from NIST might have been that you should rotate your password at certain intervals. I think it was. This is back in 2018.
We said don't rotate your password.
That was back in 2018, remember?
It was until 2017 that finally.
2017 we said
okay.
Don't do that.
Okay, very good, very good, very good. So I will not be able in my successful here. So I was hoping to play you out. So, so at this moment in time, so this actual breach happened in August of 2018. So what was the password that was breached in August 2018? Does anyone have a clue?
August 2018.
Okay, and you add something that everybody adds.
Exclamation point.
Yes, there you are.
And this is PasswordsCon.
This is PasswordsCon. This was the.
I'm not sure what language August was in.
Very good. So this was the actual password that was breached, and the professor in the back reminded me of something important here. That when we became aware that this was the password, of course, me as the head of security, I immediately had to take the blame for this because I had given them the wrong instructions. I'd asked them to rotate passwords frequently. That was very stupid of me. I had asked them to rotate passwords without giving them the means for how to do this securely and easily and in their own context and their own language. This is why it happened. And the girl who basically was breached, she's a good friend, I could say, and she has also told the story many times as part of the therapy. So we want her to stand on stage, we want her to tell her story, because she felt violated. Her secret, even though it wasn't that secret, it was August 2018 exclamation mark, one could argue, but still this felt as a violation to her. And we have asked her to tell the story openly, transparently, and the same is what we do with everyone who is then subjected to this kind of abuse. This also led to a different era in our work with passwords, and I'm quite proud of this. So this is also part of what we do. Yes, we do use intelligence methods that I still find really sexy and hot, I must say. But they're nothing more than being present on the places where criminals sell and deal in their stuff. Monitoring how they behave, measuring the value of credentials for sale on dark web. Being aware of them and seeing that who are the players, how are they operating, are there any changes in this environment? And do they have lots of passwords that belongs either to Visma or to some of our 1.5 million businesses that are our customers? Then we try to tell these people that your password is now breached in one of our authentication solutions so that they can change the password in time. And hopefully they already have a password manager in place so they can do it securely. So we then decided to give everybody a password manager, so I had to spend some money on that again because I'm terrified of that song. I didn't want to hear that again. And this is also where we have made some experiences that we would like to share with you. So I do not believe personally in using force. So governance is not a tool that I tend to employ. I tend to use free will and logic, and we tend to use salesmanship instead. Then we use diffusion of innovation as a method. So for those who are not very familiar with that, I would propose that you read up or watch a YouTube video about this because this is quite good when you want to deploy new features. We learned quite fast after buying licenses for absolutely all employees and their families because we wanted to challenge all employees with becoming the CISO of their own household. So how do you create an environment where I, as a dad, can persuade my 25-year-old daughter or my 16-year-old daughter or my 14-year-old daughter to use a password manager? And fair to say, I am the CSO of Visma. I have not succeeded in that task yet. It is difficult. It's very difficult to persuade your kids to use these things. And it's even very difficult to persuade my wife to use these things, I must say. But some have succeeded, not all. So here are some of the experiences that we have learned. So after onboarding to this tool, we have chosen OnePass. That was based on a UX process and a very inclusive process in the company. They just chose that because it seemed to do the best for most of the people inside. So we have an increase, about 300 users a month is coming in. I didn't give them a global mandate or a mandatory thing because people tend to reject mandatory. They tend to like what they can use for something practical. And at current, we are at 28.78% penetration. Nothing more. About 30% is using that specific version. But the good thing is that many of the really important ones are using it. The ones who have privileged access accounts, those who have something to really protect. So I'm quite happy with the penetration so far. Some things that we have learned is that innovators, they just want to have it fast. They use it and they ask difficult questions. But the laggards, they are almost 30% of the entire use base. They will not use it until there is no other alternative. So you have to find a way. And I think you, Per, you gave me a suggestion, because I think there's still some companies out there that share passwords as a business model. Isn't that Netflix? They still have password sharing as their business model. So maybe if you can just share the password through this password manager, that could be a way to get people to use it. So we've tried lots of different techniques, but not everything has worked. What might be quite interesting for you to learn is that these are very, very clear learnings from the process. We've been trying for over 2 years now. Multiple support channels and documentation works. So one-fits-all approach does not work. I'm very binary in these ones. One-to-one support and physical interactions, that works. To expect 100% adaptation does not work. And focus on quality improvements rather than security. So one of those things we tried, for instance, in the beginning was creating lots of text flooding. That's what we have called it. Repeating the same message. Use a password manager is important. Activate now. Many times in many different channels. It does not work. So you have to find unique ways to address each and every contextual group. That's our strong learning. And I'm sure there are some others in the room. I know Cecilia has done lots of this, but I'm more than happy to share our experiences in this field. So if you want to have this lovely experience of getting this into one of your companies, try to do it without force first. That's more challenging than just to give everybody a mandatory statement. Some other examples. So, Per, you know, me and BGs, we don't see eye to eye. So when one of my teams found this zero-touch remote code execution, I thought about kind of calling you and asking you to play Shaggy. But I contained myself, because what do you think they found when they used that one? The password, of course. So that would have been me playing BGs again. So even though the most exotic stuff we could make, we couldn't get away from the password. So the clear text password implementations in code. And this is something, again, an experience sharing from a quite seasoned practitioner in security. We have over 700 development teams. And when we take them on, we analyze their code, of course. That's part of what we do. And sometimes we see anomalies. We see large chunks of clear text stuff that shouldn't be clear text. So try to understand why. So if you have a team that has devised a good password management system, we have good hashing protocols in place, but still you can quite often, but not always, find another table right next to it where the password is in clear text, because some of them do not trust their own abilities as programmers. Of course, when the code is tested and when they're made aware of this, that goes away. But you can see that from time to time when we buy companies, that this practice exists. So do not be overly surprised if you see that on your path. So we test over 1 billion lines of code daily. There's a massive grouping of code that we do have, and in all different programming languages. And what we do see is that the password problem is still some of the most difficult things for programmers to deal with. It still is. Even though you should think it is exotic things, side channel attacks, it is still passwords. It is difficult. So it's a worthy challenge to fix. The ransomware cases that we have seen, and we see a fair share of those a year. It can be smaller things happening to customers, it can be smaller things happening to hosting providers. But what basically comes back, it is the admin passwords that normally are abused there. I think one of you mentioned it earlier in a talk, is the privileged access credentials that people rely on. Still, many of them does not have multi-factor authentication attached to it. Many of them use just very long passwords. And they have very high value on the ransomware market, or not the ransomware market, but on dark web. Generally, in the tens of thousands of dollars for a good set of credentials for an admin. And predominantly, last 7 months, info stealers has been the most used vector to provide them. So this is again data sharing from Visma. This is from the last year. These are the cyber attacks that we have seen, and just put into a pie chart of what are the different categories of attacks we see against us. And as you can see, when you really dive into this one, most of it is related to either using a stolen password or finding a password. So I have to give it to you, Pat. I have to give it to you. Passwords are sexy. They are damn sexy. I was hoping to avoid saying this one, but it is damn sexy. So when I got the chance to give a small homage to Per, I took the opportunity. Of course I took it. So this last opportunity was on NDC security. I was there together with Daniela Cruces, a professor from NTNU, and we were talking about some advances we have done in the research around application security. And of course I had to talk about this little feud between me and Per. And I must give it to you. When we started this out, I was quite pig-headed. I thought this is going to blow over. But the passwords is still, so many years later, still our biggest problem in the industry. It still is, and I think it will continue to be so for a very long time. So at least from my perspective, you have won my heart. From being the one who is really into sexy side channels, I now actually find passwords quite sexy. But what I also have to give it to you is that you have ruined BGs for me forever. You have ruined it. And my kids, they have also said to me, Espen, is it Per again, whenever they hear this song in the background. And this has been going on for too long now. So can I stop play BGs now? Is it okay, Per?
What did the audience think?
Just play it.
Should I just play BGs? Okay, here it goes. Now you know, Per. And this has been a soundtrack for myself for a very long time. My closing arguments today. Passwords are more important than exotic and sexy side channels. I admit to it, Per. It is much more important. Per is right. I was wrong. I was wrong, Per. Very wrong. Friendly bets are fun, and pain is so close to pleasure. I actually started liking this in the end. And I do completely agree, BGs are evil. They are very evil. And this is a good friend of both of us. This is one of my colleagues, one of our colleagues. And for those who don't read Norwegian, it says use two-factor authentication on his license plate. So he's one step more advanced than you. His name is Christian, and he's a good colleague. Any questions from the audience? Yes, sir.
Really fascinating talk. I was curious if you got any insights into how your employees were actually using password managers, and so did you get any ideas of whether there were still things like password videos, just because that's something we've noted in the past, even for people that use password managers.
So you're looking for the experiences to how our employees are using it?
Yes.
Yes, we have seen some different methods of using it. Some have used it almost as described by Per Torsheim, like really do the full automation part of it. But many teams, they use it to create their own vaults, like key vaults inside a team, where they need to have some kind of shared credentials for some important stuff. Others have used it for just as a method to avoid having everything, just have the same password everywhere, so to avoid password reuse. So we have seen many different use cases. I don't have the data with me, but I would be happy to share it at some stage. Yes, behind you.
Yes, kind of following up on what you mentioned. Again, great talk. I wanted to know that what kind of training or encouragement was given from the company for people who were early adopters or others, and what were the pain points for the laggers, and why did not they accept they use password management?
Okay, I can go back to those slides on that one, so to have them up. Hopefully we can avoid all of these Bee Gees things. There you have. Here you have some of the characteristics. So the group that has managed this for me, we chose to do this in the security communications groups, where we had lots of people who were quite extroverts, who was able to kind of communicate quite rapidly. And we also had a group together that is very technical. So what we learned, that the innovators, they were quite aware of what this was. The only thing we needed to say was that, yes, we do have this now available, and it's free, by the way, because the CSO takes the bill. So anyone who wants it, come get it. So for them, it was just the availability of it. They just wanted it fast. And they learned very, very fast. And then they tried to bring others with them. So each innovator could bring another innovator or maybe an early adopter with them. But what we also learned after a while is that when you have gotten most of these innovators in, you might have to change the setup of the team who delivers it. So what we also learned over the years, because we've deployed many security services over the years, is that to get these laggards, the late majority of the laggards, to really come in, you have to make this as good. The usability has to be flawless. It just has to work for the first time. And many times we've been standing on stages and gotten questions from some person who I identify as a laggard in the back of the room, who would like to get this to work for them. And what we then have had to give as advice is that if you are a Mac person, if everything in your life is on a Mac and an Apple iPhone and iPad, so just use what is in there. It's probably good enough for you. You don't have to use the one-pass solution. It's okay. And for those who are really fond of whatever other password manager they have, we have encouraged them to use that instead of changing to this one. So we have had to open up for many ones, even though this is free. That is not enough incentive for many. Even the monetary saving is not enough. They just want to decide for themselves. We have seen this on early majority also. If they fail, they need one-to-one support in their own language, physically available. That is best for them. And they want that support to be very practical and private. So we have been standing on stands in the canteen, just with a password manager banner over our heads, and people come there and sit down, and they get some help in their own phone, in their own laptop with this. It's quite costly. Yes, Professor?
Yes, we discussed it briefly before during the break. But I used the story from Visma and the hack
cool.
To explain how we need to take care of people who have caused an incident. And you were lucky because you noticed very quickly and you locked down AD and you told everyone to change their passwords, etc.
Mm-hmm.
Other companies or organizations have not been so lucky.
Yep.
And the person with the weak password or the person who clicked on that link usually don't go around and give talks.
No.
Because they are traumatized.
Yes, they are.
So therefore, that's an important message to companies. There are no stupid employees. It can happen to the best.
I do agree.
Can make a mistake. So it's basically the company has not been able to educate everyone, or that's the attitude. So the company must already have a policy to take care of.
But of course.
An employee who has caused millions or billions in damage. It can be. We have some good examples in Norway, the Norsk Hydro or the municipality Østre Toten. I don't think these single persons are happy to go around and give talks about the incident. So
No, I'm sure they can't. And we also have that as a practice. One of my colleagues, an esteemed doctor also, Monica, one of her experiences is that some piece of her code in a previous part of her career was stolen by criminals and offered up for sale. And she has gone around in universities and told these stories. That's empowering also from your own perspective, because when you tell your own story, when you are allowed to share it, and also you are encouraged to share it, this really builds your own character. And she's now the director of development for me. She's bloody good at what she does. And these are things that help you. So lift these people that have been unfortunate. And to be honest, the case with China, that was my fault, because I had not given them the right directions. And this also brings me to something I'd forgotten. That is that when I look for advice on passwords, I ask Per. I do respect NIST, but I respect him more. That's good. Any more questions? Yes?
Yes. Password manager.
Yes?
Team vaults. Team vault owners, orphan vaults. Is it a free for all? Can anyone create a vault and invite them to the vault and so on? Or is it a managed service? How you manage vaults beyond yourself?
No, we have tried to make this create your own. Of course, supervised. We can see what vaults are being produced, and then one could ask them, are these for good? So it takes active operations to follow this up. But I tend to put as few limitations on people as possible, because they always teach me something that I didn't know from before. If I control them too much, they will do as I tell them. Yes, they will. But that might not be the best or the perfect way to use this technology. So I want them to experiment. Yes, sir?
Do you give advice on storing personal passwords in this corporate password manager?
Oh, yes.
And is it allowed? Should they have a separate vault, or how does it work?
They do have separate vaults. They have private vaults also. And it's been lots of discussion. Should they, if they quit Visma, of course we will help them with exporting their own data. Of course, that's just it's a good service from us.
Can I comment on this?
Yes, because.
We've got a license contract. I work in Visma, not in security, but I work with identity and access management. So when I heard about OnePassword, I told my team that it's mandatory for us. So we moved from the previous, from KeyPass to OnePassword. On the account of your question, OnePassword gives an offer, makes an offer of a free account for your family, and then you get a separate account. So basically, you get two accounts in your OnePassword. One personal, one company. Once you leave a company, you have to buy subscription in order to continue using personal. So they kind of hook you up. It's a deal for them. It's an amazing idea. Because once you are already using one password manager, you kind of getting out of it is really complex.
Cecilia?
Just tell me, there's a detail that I would like to add to that, because you're allowed to use your vault, you just can't make any changes to your vault. So if it turns out that I'll bring my password out, I leave the company, I bring some of my password with OnePassword, or some of the other providers that do this, some don't. I can just have it there for a while and then decide if I want to renew and pay for it myself, or if I want to export it into something else. A lot of the time, yes, you do stay, but you don't have to pay. It's very important part of
I agree. Yeah. And that was also part of this my little rant on this, is that we will of course offer help for those who would like to export their data to somewhere else. We don't think that OnePassword or any one of the others owns the future here. There will come something new and better, I'm sure. And this also is because we see an aging population, and it's difficult to use many of these things. And some of the really clever people we have problems using this technology already. Even though I find it relatively simple, many people find it very difficult.
Can I ask you an audience one question? We started with how many people have how many passwords. I would like to ask how many people have a OnePassword manager? How many?
One or one password?
One password. One. Two password managers. Three password managers. Four password managers.
No.
You see
I have three different ones. Yeah. Any more questions or things you would like for me to share? And please, if you are in academia, reach out. I would love to work more with researchers who would like to study. And we are quite good at sharing data. And my primary researcher is also a professor at NTNU. So if you are a doctor and would like to be a double doctorate, maybe you can be there. Or if you'd like to do a PhD, maybe you have doctor. I think that's a big thing in Germany, isn't it? Yes?
How do we reach out?
Hi, Mespen. Hi. That's how. It's easy.
I tried to find email addresses of CISOs, and it's quite difficult.
No, it's he knows it, and I know it, and he also knows it. It's easy. Yes, I'm here.
Okay, then again, thank you, Espen.
Thank you.